Welcome back to the Game Engine series live. Today we are embarking on the amazingly long journey. Probably not going to be that long, but we're embarking on the next new major feature for Hazel 2D, which is C# scripting. We're probably just going to dive into it. There's much I could say, but as we've discussed, this series going forward is going to be more about doing rather than saying, because we have a lot of work to do. I will kind of say though that in terms of like how we'll be implementing this, we're going to start off by just downloading and building Mono, and then we're going to kind of fumble our way into like discussing what the API offers, how it works, how we're going to integrate it, how we're going to use it. I'm going to try and explain everything as I go along with it. And the biggest reference we are going to use is going to be Hazel. Because Hazel, the big version of Hazel, has been using C# and Mono for like the last 2 years, I want to say. And our scripting engine has greatly like evolved over time. There was an initial implementation written by me. And then Peter, who is an engineer on the Hazel team, he kind of took over that, and he now is kind of responsible for that system in the game engine. And he has kind of refactored it and improved it over time, upgraded it, done a lot of that kind of stuff. And it's changed so much that I don't even personally know everything about it, because Peter's in charge of that section of the game engine. So I'm going to be consulting with Peter throughout this journey. I'm going to be actually following a guide that Peter made, which is very exciting, and I'll link everything. For those of you watching on YouTube, you'll see all the links in the description below, but otherwise I'll show them on stream, obviously, because he actually put together a pretty nice guide on how to get started with Mono. I have obviously had a chat with him over the last week, just so that he could kind of, get me up to speed with what the scripting is like currently in Hazel, but it's pretty powerful. We've been using it for a while, as I mentioned. We've built quite a number of games on it. It's got like full debug support as well, which is great. And actually there's even a Visual Studio extension that you can download called Hazel Tools, which I'm hoping that will also should work with Hazel 2D as well. And that lets you kind of, while you're playing your game in Hazel's editor, you can place breakpoints and inspect variables and catch exceptions and do whatever you like, a normal debugger. So it's pretty, the implementation is pretty detailed. Stuff like debugging we'll get to in the end, but basically that's like the plan. So the first thing we're going to do here is basically just dive in. Actually, the first thing we're going to do is tweet this, because I always forget to do that. Let's quickly do that. But yeah, how's everyone doing, stream? The first thing we're going to do is probably discuss where on earth we're going to get, serious scripting, where on earth we're going to get Mono from, because I have a feeling Peter will probably join later. I don't know if he's awake yet. I did send him a message. Oh, good, he's typing. I can see him typing in Discord, because I don't even know where to download Mono from. I'm pretty sure the .NET runtime repository is... Nope. He's saying no. He's saying get it from Mono. Okay, sure. That was just in time. I'll ask him what the difference is, because I am curious. But anyway, so we're going to kind of dive in and this is... I'm a little quiet. Okay, is this... Well, that's probably too loud. Is this better? I'll lower the music a bit. Oh, wow, the music is quiet. Yeah, I'll lower the music a bit. Is this better for music versus everything? What was I saying? Yeah, this is going to be an interesting implementation, because it's going to be pretty much live. And that's kind of the point of the format of the series going forward, right? But it's going to be live in the sense that, I don't know what I'm doing, basically. So this is going to be fun. We're going to kind of collaborate on this. You'll probably see me asking Peter questions and Googling stuff and, working as I would work, if I was programming something for real, because this is what I'm doing. I am programming something for real. So hopefully that will be useful for those of you who are interested in that kind of content. So Peter has some kind of Mono guide, right? Which I'm going to link. So this is kind of what we're going to follow. Let me just switch over to this. So this is Peter's thing. So it's peter1745 github.io. Oh, Peter's here now. I'm going to just post it in chat. But basically that is like a nice little piece of documentation that Peter has written, which, let me just make this maybe a bit brighter, which is basically, like, it's not that detailed as far as I'm aware. Like, it doesn't contain everything you need, but you can see that it's got like a bunch of stuff here. Building mono, cloning from GitHub. Yeah, so you can see this is what this is the guide, I guess. So this is where we're going to be cloning it from. And building classic mono from source. So he said it was pretty easy to build. So building mono on Windows is ridiculously easy. It's what I like to hear. Most likely easier than any other platform. I will note that using Visual Studio only works with building the mono runtime libraries, not the .NET libraries. That's okay. I don't think we need to build those, do we? In my case, I won't be building the .NET libraries from source. I'll be getting them by installing mono locally and copying them from the install directory. Okay, that's interesting. If you want to build the .NET libraries, you'll need access to the make command, which you can use. But yeah, so that requires kind of like Linux binaries. So prerequisites, an installed copy of mono. Okay, so let's get that, because I don't actually think I have that. And obviously, guys, I could copy all of this stuff from Hazel, but I don't want to. I want to show you how I would go about implementing this if I didn't have, like, obviously, Hazel Dev, 3D version of Hazel. By the way, those of you who are interested, you can access the full version of Hazel by helping to support us on Patreon, by going to patreon.com/thecherno. Aside from helping to support, obviously, this series and all of our work that goes into developing Hazel, you'll get access to the big version of Hazel, which is much more advanced than the Game Engine series. So that's a good reference if you want to jump ahead in the Game Engine series, because as I mentioned, I will be referring to that as well, and we'll be hopefully, we'll hopefully be kind of creating an implementation here in the Game Engine series that's going to end up being similar to the implementation we have in kind of the big version of Hazel. Okay, so let's see here. So we should probably install mono. So let's download and install the mono runtime. So we'll go with 64-bit, I assume. Don't really need GTK Sharp or whatever. Those libraries are not something where, as far as I'm aware, GTK Sharp is some kind of like windowing library, or I don't know. Yeah. Let's install this. And then, yeah, like this is going to provide us with the binaries that we need. So let's kind of also clone this. So I'll go to my little Hazel 2D thing. I'll just make a little directory called lib git clone recursive, and yeah, we'll just check out mono. I'm assuming just the main branch is probably what we want. I mean, there are specific release branches, right? So I don't know, maybe we should get a release. Peter, what do you think? Should we get a specific release, or do we just clone main? That seems like it might be dodgy, especially because there's an X here. And the build might be failing. I mean, it looks like it's passing here, it's just not everywhere. Don't know. I guess we'll get main for now. Either's fine. Okay. Yeah, I'll just get main. Alright, so we're cloning mono. We're installing mono. So mono would have installed, obviously, somewhere on our computer. And I'm assuming that wherever it installed to, it's also going to contain libraries there. So it's just in C program files mono. And then we have, I'm assuming some kind of, well, no, this is like, these are not the libs. Maybe they're in lib. Mono source libs. Mono? Yeah, here we go. Yeah, so like 472 API, for example, all of these kind of different versions, these have the actual binary. So I recognize some of these from Hazel. Oh, but probably release. Yeah, I didn't get release. It's okay. We'll build this version of Mono. We'll see what happens. What version are you using in Big Hazel, Peter? We'll see what he says. So, yeah. So I'm not really sure, like, which binaries to take. I'm not sure if they, yeah, I guess they do include all of them. We'll just take the latest, I guess, which is, well, 4.8 is the latest. But is that supported? Not sure. So these are like these are all of our C# libraries, right? So C# obviously is a language, which comes with a whole bunch of binaries. I might have to install .pig here as well, which is annoying. There's probably some old version. Let me just install this here so it's not intrusive. What is that? No, I don't want that. I just want the standalone. Okay, whatever. There we go. So yeah, so these binaries, we'll kind of talk a little bit about how they work and everything, but these are basically inside the library here. So Peter's saying 4.5. Is there a specific reason why we need to load 4.5? Is that going to be the version we're going to use? And if so, why? So one thing that kind of confuses me with Mono is like, and I always bug Peter about this, and that is basically like, how do the versions work? Like, what can this support? Like, what version of .NET? What version of C#? The actual language version, right? How does all of that work? Because I still don't understand that. But I will say that basically, like, these library files contain like the functions that you use as part of the C# API that you're probably all used to. So for example, the biggest one is system.dll. I mean, it's not literally the biggest one, but it's the one that you probably want to use. So much stuff. So if I load system.dll, which actually is already kind of here, but if I drag this DLL into jetbrains.peak, it will load the DLL, which is here now, and then you can see what it contains. So this is very useful because when we end up building DLLs, we can easily see what they contain without having to like, I mean, we might write some utilities in Hazel to be able to actually dump this stuff, but .peak obviously is something reliable that we can use. And you can see that it's got all of the different things that's contained here. Now, system is a big one, but there's actually another one called MS-core-lib. So MS-core-lib, yeah, is even bigger, and that's kind of the core one. So it's interesting because system doesn't actually have all that much. So you can see that like system.io doesn't even have like the normal file writer or whatever. It's because it's all in like MS-core-lib. So if we look at MS-core-lib, you can see there's also a system namespace, and that's where really all of the stuff is. So the system.dll has a bunch of stuff, but I think it's important to understand that as far as C# goes, a lot of the stuff that you're looking for is going to be in MS-core-lib, right? Because, yeah, it's just got way more stuff. So that is like a really important DLL that we need to make sure that we load in Mono, otherwise it's not gonna work, right? My .peak's like a year old, yeah. I didn't bother. I mean, I know it looks like I just installed it, but it's because I hadn't installed it from a year ago, and it doesn't really matter. I don't know what the UI looks like now, and I don't care. But you can see in like system.io, right? It's got like the stuff you're probably used to in C# for like reading and writing files. So we've got binary reader, binary writer, and then stuff like no, I don't know. The main stuff, whatever. Where's the file writer and stuff? Or what's it called? Oh, file. Maybe I'm thinking of file. Yeah, I think file. So the main file API and everything, it's all like, for example, I'm just using file as an example. But my point is MS-core-lib is like the main one that contains everything. And then system is like, I don't know, it seems like it should be the main one, but it's really just MS-core-lib. All right, anyway. So yeah, that's important to know. Okay, so yeah, Peter's also saying not 100% sure why, specifically version 4.5, but all I know is that 4.5 has the real library and the API folders only have reference assemblies from what I understand. Oh, really? Okay, so the dash API stuff, Peter's saying has reference assemblies, which I guess kind of makes sense because they're all really small. So if you look at system DLL, it's like 400 kilobytes, right? Whereas the one inside 4.5, like these are substantially bigger. This one's like 2.5 meg. So maybe these are some kind of, I don't know. Yeah, MS Core Lib has all the collections. It's got a lot of stuff. I don't think it's got all the collections though. Because I remember some of them needing other things to be linked in. But anyway, so these are kind of the libraries. Now, if we look at, let me just quickly find something for reference as well. So we actually, this is something we can talk about, which I think is kind of interesting. If we go to the Studio Cherno itch.io and we look at Forest, so Forest is a game that we made and shipped for Ludum Dare 50, right? So let's go ahead and download this. Oops. The reason why is this is obviously a game that we've made and distributed, right? So, and this uses C# for scripting as well. So this was made in Big Hazel, not in Hazel 2D, of course, but obviously this is a good representation of what the end goal is going to be for Hazel 2D as well. So I want to show you guys kind of what ends up making it to a shipped product and what we actually need. So, and by the way, for those of you, I mean, I'm not probably going to play the game, but just in case no one has any idea what I'm talking about, if we just launch the Forest launcher. So this is like the game, and then we can hit play, and then voila, we are playing this game called Forest. So yeah, turns out this is actually going to be a little Forest Let's Play, for those of you who don't know how to play. Remember this, Tim?
Speedrun.
Yeah, speedrun. Oh, I never made a little speedrun thing. It's funny, some people didn't know that you could kind of turn around to get some lighting on this. So it's like, oh, what does it say? Anyway, this was fun. All right, is there music? Well, there should be music, but I can't really hear it. All right, Alt F4. So basically, if we take a look at what's actually shipped as part of Forest, right? We have inside Mono and Lib and Mono and 4.5, right? So this now kind of matches what I'm talking about here. So in Lib Mono, inside our Mono installation directory, we have all these API folders. So there's 4.5, right? And it's got all of this stuff here. But the stuff we actually need are just basically these three. And that's why and that's because MS Core Lib, like again, contains literally everything that we ever use, right? So like, and obviously I don't mean literally everything because otherwise it would be the only one there. But I mean, MS Core Lib contains like most of the stuff we use by far. And then I guess we also, as part of the scripting for Forest, we also use system.core.dll and system.dll, right? Those need to be included. And the thing is, when we actually like use Visual Studio to build our main binary, which in Hazel is located in where would that be? Data, assets, scripts, binaries, and then here it is, ld50 gameplay.dll. This is the actual script binary. All the stuff that's basically when we build this in Visual Studio, when we add references, as you'll see later, we kind of have to add, like, you know, if we want to use stuff from system, we add system.dll, which might be by default there, or we add, like, what was the other one, system.core.dll, right? So as you add DLLs here, you also need to make sure that you obviously ship with them because they're going to be required, and they might get like dynamically loaded as you call a particular function, possibly as well, right? Although you can load them manually with Mono as well. Okay. Okay, so yeah, so that's a little bit of a demonstration as to kind of where we're heading with this, and also how Mono. I thought it would be interesting to kind of show, you know, how Mono gets shipped in a way, because at the end of the day, right, all we actually ship with Mono are these three binaries. Well, in the case of Forest, if you use other things, you'll need to ship other things, but that's all we used from this actual library, even though this is huge.
All right, yeah.
You're off, see ya. So in other words, like, you know, there's not that much stuff to ship in the first place. I'm just gonna go to a darker screen. There's not that much stuff to ship in the first place. And so, and then the actual, as for the actual Mono binaries, right? Because this isn't obviously the C# runtime. This is just like the C# libraries. As for the actual Mono binaries, the way that works is if we look at Forest, you can see we have a Mono DLL here, which is a native DLL, and then actually we've got async in Forest's case as well. But Hazel itself is entirely statically compiled into this binary that's about 8 megabytes. That's the entirety of the Hazel engine. And then any additional DLLs that we need, we only need 2 in this case, and that's mono and async, because we don't compile mono statically and we don't compile async statically. Don't really know why. Like, Peter, why don't we compile mono statically? Is there a reason why I can't compile it statically here for the game engine series? Because obviously that would just mean we just have, because we don't even need async. I mean, async could also be statically compiled, but it's not here. And it would be nice to just distribute a single exe. So I think I would probably try and compile mono statically, unless Peter really discourages it for some reason, and he has to have a good reason. But that's kind of one thing I'm thinking of as well. Okay, but anyway. What we'll do to begin with is, obviously we've just checked this out. Yeah, okay, Peter's saying go for it. I probably should check out a specific tag, though. So this is 605. I mean, this shouldn't be that difficult to check out. If I just do git checkout 605, inside, obviously, the mono directory, that will just take me to that checkout. So I might just do that, just because we know that's a safe checkout, right? So for those of you who missed that, I just went to mono, and then there's tags over here under releases. And then if we click on these tags, then we can see all of the different versions. And then they have like a commit like a commit SHA, or like a GUID or whatever that identifies that commit. And then I've just done a git checkout there. Okay, cool. So switching okay, that's okay. I'm not going to commit, obviously, to this, so it's okay. And if we just open this in fork to see what we're dealing with, then we can see that we are specifically, obviously, on this release now. So it's important just to make sure that we know what version of mono we're dealing with, what version of mono we're building, because the plan here is going to be, we're not going to really add mono as some kind of submodule. I don't want to do that. I'm actually going to directly commit mono binaries. The reason why is because I don't want to, you know, if you have a look at how the big version of Hazel is structured, like, we try and include things as submodules wherever practical. But the problem is, this is really back from like February 2020, by the way. Seems a bit old. Well, no, it says 2022 here. Weird. Because it seems to match this branch as well. Well, whatever. Yeah, submodule would be better. It's just going to be huge. Like, it's gonna mean that checking out Hazel is going to take longer if you do a fresh checkout, because you're going to need to check out the entirety of mono. And it's just not something I really care about. Obviously, if it's an open source project kind of like this, and you're aware of how to actually build it, right? Then if you want to introduce a new platform or update it, then you can easily just clone the base repository and build it separately and then commit binaries, right? Now, committing binaries is another story. Like, do we want to commit binaries or not? Do we want to, you know, kind of, like, some debug binaries can be like, I don't know, a gigabyte. A gigabyte's probably a lot, maybe a few hundred megabytes, which can be, you know, with debug symbols and stuff, PDBs, and it can add up. So I understand not committing binaries as well if you don't want your Git repository to be huge. In which case I'd probably just serve them from some kind of server to download. I don't know, like, it really depends. Like, my kind of, the way, I won't say that I'm doing it the best way, but what I will say is that it's just really easy to commit a binary. And obviously for Hazel 2D at the moment, we're just supporting Windows. When we do support Mac and Linux, we can just add Mac and Linux binaries, and that should be okay. So that's our plan today. We're going to basically build mono, which Peter says is ridiculously easy. And we can follow his building mono guide, I assume. I'm not sure if we really have to, because I'm assuming that, so if we go to mono MSVC, and it actually already comes with a solution apparently. So we don't even have to generate a solution, it seems. So if we go into the MSVC directory inside the repository, then there should be a mono.solution file. So we're going to open that up. Don't know what version of Visual Studio. That should hopefully be using 2022. Yeah, looks like it is. And then there's going to be a bunch of stuff. Now, if we kind of reverse engineer this a little bit, if we take a look at Forest, which we just downloaded and extracted. Then inside forest, you can see we're using mono 2 sgen. So this is actually the library we're trying to build. Because there's a lot of stuff here, right? But if we expand all of these, then we will eventually stumble upon... I'm actually not 100% sure if it might... Yeah, mono target suffix. We might not 100% be able to see it, unfortunately. I think this might be... Whoops. I was hoping for something that would just say sgen, but I think that's changed a bit now, hasn't it? Yeah, so you can see this is libmonostatic sgen. So sgen is like the mono target suffix. Sgen, what does that even mean? I don't know why it's called sgen. But basically, this is the target name, right? So it looks like what's happened here is it's just mono 2.0 sgen. That might just be this mono thing. Oh, now it's not responding. But that doesn't have 2.0. This is just mono sgen. So sgen is the garbage collector. Huh, interesting. Okay, well anyway, this is an exe file. And then we have a dynamic library. Oh, here we go. Target name mono 2.0 sgen. So this is it. So libmonodynamic is what I believe, via my reverse engineering, Peter has built to get this DLL because it matches perfectly. But what we're going to do is we're going to mix it up here on the Game Engine series. We're going to build libmonostatic, and we're going to try and go the static route. And again, I don't know if it's going to work, right? This is live. This is dangerous. Do not try this at home. No, I'm kidding. You can try this at home. It's not that big of a deal. But anyway, so let's just go ahead and build that. So we're gonna obviously build two configurations, debug and release. So starting with debug, libmono, static, let's just right click on that, hit build. And if Peter is correct, and I do have faith in him, it should be a very easy process. I just noticed that the camera looks very yellow, very warm. I don't know, do you guys like the warm vibe, or do you want me to make it a bit more like properly white balanced? I mean, it is pretty warm because I'm using mostly warm lights. Okay, someone also asked a question. Sorry if repeating the question. I was recently been looking towards Rust. Okay, so by the way, debug built here. So let's just quickly grab this directory so we don't lose it, and we'll build release while I answer this question. Release. So I was recently looking towards Rust and discovered it's quite safe and pleasurable to write in. I like that. AKA better than C++, C#. May I ask why you haven't used Rust in your Hazel Engine project or moved towards it? Mostly just because, like, to me, the programming language is a tool for the job, and like I have absolutely no issues with C++. Like, I think C++ is fine. Would Rust be better? Yeah, probably. But the amount of engineers that know Rust well that would be able to like contribute, you know, like, does Peter know Rust? Does Tim know Rust? Does like 0x and Jay and all the other people on the Hazel team, do they know Rust? Like, I don't think so. I don't really know Rust very well either. I'm sure I could learn it if I wanted to invest the time into it. But like, you know what I mean? Like for me to switch to Rust, there would have to be something extremely compelling. But to me, like, again, C++ is perfectly fine. Like, I'm very comfortable programming in C++, and I'm aware of certain mechanisms that obviously can introduce bugs, but the idea with C++ is, the way I've always thought of C++ is it's a language that expects you to BYO tools, right? So you're supposed to bring your own, you're supposed to write tools into the language to help you out. And that way you don't get tools forced upon you, like a garbage collector, for example. Those aren't forced upon you, but you can write one of them if you want for your own stuff, right? So, like, ultimately speaking, that's why, like, if you have that mindset with C++, then be aware that it's pretty bare bones and you will have to write your own protection stuff, and possibly extra things like asserts and, you know, whatever in debug mode or like in debug configurations to maybe help you hunt down memory things. So I have custom allocators and all of this other stuff, and obviously be responsible with your memory like ownership and whatever. But I think like that's fine if you understand that. And again, nothing against Rust. From what I've heard, it's great, and yeah, people do seem to love it a lot. But it's just like, to me, I guess, like, to me, the product is Hazel, and what I use to write Hazel isn't really that important, as long as it does the job. And so far, C++ is not limiting us. Like, that's the thing, you know? I'm not like, oh man, we have all of these memory leaks and all of these bugs. Oh, if only we'd used Rust, like, life would be better. No, that's just not the case. And again, like, people go on about build tools and package managers. I have no issues using Premake at all. Like, our current build system in Hazel, like, I don't know, rest of the team, I mean, I know Peter and 0x is in the chat, but is the build system getting in your way? Is the package manager, like, is the lack of package manager, like, getting in your way? Not really, and we've shipped games with this thing, so, I don't know. I think it's fine. That's why, like, yeah, I get that Rust is probably better. Like, but the thing is, it's not good enough for us to, our current situation is not horrible enough for us to be like, yeah, we need to invest a huge amount of work into switching. So that's, yeah, no, I definitely do not like CMake at all. I hate CMake so much. Anyway, don't get me started, 0x, on that. All right, cool. So we've got these two things. The only good thing about CMake is the fact that it's a bit more popular and universal. That's it. But other than that, I think it's garbage. All right. So, oh, well, yeah, no, actually, the other thing that CMake, well, again, the fact that it's popular and universal means that libraries generally have CMake files like out of the box, so you can just add another library really easily. That's really the only benefit I see. What's the link you sent? Mono project, Visual Studio, MS build properties. Oh, it's so bright. So what's this? You may want to tweak one of those for a proper static build. Why? Oh, I mean this stuff. Probably. Okay, well, we'll whatever. We'll try the default version just so that people don't get too confused, and then we'll adjust as needed. But yeah, anyway, so we've got the two static stuff. So we've got libmono static sgen, which is 39 meg for the debug version, and then 33 meg, which is pretty big, for the static version. That is huge. Why is it so big? So libmono static sgen, there's libmono runtime sgen. What's the difference? I mean, this is kind of what we wanted to build still, but damn, these are huge, and we possibly need like all of these. These are massive. Weird. I can't believe these are so big. But whatever. We'll see how we go. But yeah, guys, we've just built mono. Like, that was really easy, right? Peter was right. Very easy, because again, it comes with a Visual Studio solution out of the box, like already ready to go. So if we get back into Hazel now, we can start on our scripting journey. So what I want to do, the first thing I want to do is back in Fork. We're currently on the master branch, right? We have, it seems like we have, we played, I think, with the cameras. All right, we wanted to add this I guess we do want to keep that, don't we? Because we changed the example to actually include like the textures. So I think I do probably want to save that. Let's just run this quickly just to see where we're at. But yeah, I'm pretty certain we want to save that stuff. I think Visual Studio is much better than C-Line. Visual Studio is great. No problems. Apart from when it crashes, but everything crashes. Okay, so scenes, example. Yeah, so right, we probably want to keep this situation. So I'm just gonna just say updated example.hazel scene to to use textures. Everything crashes except for Hazel. Hazel doesn't crash. Hazel just collapses. All right, so let's see. What I want to do now is branch off from this. I'm going to make a new branch. We're going to call it scripting. We should have checked it out, but we can check it out here. Without changes, like I don't think this is not a real change, and this is just I'm GUI. So we don't really have changes. Let's just check out to scripting. Now we're on the scripting branch, and this is going to be important. I mean, we could push it or whatever if we wanted to make sure that it exists on the server, but we're going to commit to it and push it as we add mono. So the first step obviously is to add mono. Now there are a couple things aside from obviously building, debug, and release as we've done here. We also need to make sure that, let me just make sure this is all nicely organized. We also need to make sure that we obviously have like the include stuff. So I think there is, so where is it? Mono, MSVC. I have no idea where, this is just mono. I don't know where mono has all of its include stuff. I did see it in the mono runtime installation, but I'm sure it's probably in the repository, right? So, like, we should have the actual header files and stuff like that here. I never know where. I remember loosely what we could just search, right? Let me just use search everything here, and I think it's like something like mono.h. sgen mono, so mono metadata. What's the main kind of mono header file situation? Mono utils, mono config, mono debug. There's a bunch in mono utils. Mono math. So this is why, okay, so Peter says in the MSVC folder there's something there. So this wasn't in the MSVC folder. But let's take a look at the MSVC folder. In what build? Don't think so. No, it doesn't look like there's any includes in here. So let's maybe, you know what? Let's maybe take a look at Hazel dev. Because I don't even have that open. I should probably open that. Probably, I have no idea what branch. I think dev is what I've called it. All right, let's take a look at Hazel. Okay, so if we take a look at something like scripting engine or script engine, I just want to see, yeah, so, okay, so mono metadata. So a lot of it is in mono metadata. And then if we take a look at this stuff, then yeah, most of our header files are in here. And then where's like more general ones? Do we have more general ones? No, we don't really include mono in our header files, and mono JIT as well. So this kind of stuff, and then mono metadata, mono metadata, mono JIT. And so this is kind of like the stuff actually. Oh, this is include. Oh, that's our include. That's in Hazel. That's in Big Hazel. So in that case, what we are looking for is I think it was just mono and then metadata. Yeah, but this includes all the C files as well. MSVC build sgen, Peter is saying. But I thought I checked that and it didn't look like it was there. Or did I not look carefully enough? MSVC build sgen. Yeah, but what? Where? There's no includes here. These are intermediate object files. They're not here. So hence why I'm not there. Yeah, like the thing is, it's all here. Like if we go back to search everything and I put this back, right? We have all the header files here, right? Here they are. And that's it. That's across mono. That's across mono, inside JIT, inside metadata, inside all these directories, right? So we've got like 2 in JIT, bunch of metadata, bunch of utils. So we could just copy these. I just don't know if there's a proper way. But the thing is, yeah, maybe I didn't build it properly. I didn't really, like, again, I didn't do a Control-Shift-B. So maybe if I do a Control-Shift-B, it will copy those, like, include files. So let's try and do that, because that way we'll, obviously that's like the more, like, it'll just be easier. It'll just copy all the include files for us, instead of having us manually go through and copy them. So let's go ahead and do a Control-Shift-B, and we will wait. So then that should be, that's dev, that's Hazel dev, Hazel big Hazel. And then for Hazel 2D, so yeah, so this should be now in build sgen. So let's see if this produces like an include directory or something like that. We'll see. So far, nothing. Unless it goes like somewhere into here. Maybe there's an include directory that pops up. Nah, it doesn't look like it does, though. So, don't know about... Oh, there it is, include. Okay, so it's not in build. Okay, include, mono. Okay, and then here's all the stuff, right? So I don't know exactly what does that. I didn't really look hard enough. But one of these does the okay, here we go. Copying mono include files. So that's number 9. And 9 was let's look for 9. Where's 9? 9 was libmonodynamic. Don't know why it's specifically the libmonodynamic. But libmonodynamic is the thing that looks like it does the actual copying. And so that means that we now have obviously our includes. So let's grab that as well. And if we head on over to our Hazel 2D repository, inside Hazel, vendor, and mono, I'm going to copy all of those includes. So let's make a directory called include, and we'll put mono into there. And then I'm also going to make a lib directory. And then this is where basically those debug and release libraries that we built, that's where they go. So all up, this is going to be kind of heavy, 150 meg, right? I don't know if we need necessarily all of these yet. And then obviously into here, like, I mean, if we had DLLs, we'd make a bin directory and then put the DLL there, but we'll see, we're going to try and do it statically. And then finally, obviously, like the license file and stuff, we should retain. So if this has some kind of like license, I don't know exactly, I think the license is fairly okay, but usually I like to slap a license file in here. So this is just BSD, and it probably says you have to include the license with it. So there you go. And then if we want, like, we can obviously like include like the README. I don't know, it's up to you, like what you include. I think the README is probably fair to include the README as well, just so that it's clear what this is. And possibly if they've got a version file, which they don't, that might have been useful. All right, cool. So that's basically the mono thing. And then we would take this and commit it. Now I'm not going to commit it yet. I'm going to try and link this and actually see like what we need and if it works and all of that stuff. So how do we link this stuff up? Well, again, this is where like the reference implementation that's in Hazel comes in handy, because what we can do is we can take a look at dependencies inside the Hazel, the big Hazel repository, and we can see, for example, when it comes to mono, so we include obviously the include directory, and then we for the library directory, it looks like we just include, well, in this case, mono 2.0 sgen.lib, right? This is linked dynamically, but that looks like the only thing we include. This is the library directory, but this is library, right? So obviously this will include either from the debug directory or the release directory, but it's just a single lib file, and I would expect that because it's gonna load the DLL at runtime. But yeah, I'm not exactly sure why. I'm not exactly sure how that's gonna work with us because we have a bunch of these things, but we'll see. Okay, Peter's also saying typically for a static build, you would set the mono use static lib monos to true in Visual Studio Property. I'm sure building the static project. Well, yeah, I'm assuming building the static project should probably have that defined. So mono use static lib mono. We could probably quickly just check if that's defined, but it might be difficult to see. Where is this? This doesn't even have the C++ compiler thing. This doesn't even have any files. So yeah, probably, I don't know if it includes certain directories, whatever. It's too difficult. We'll see. Okay, yeah, so what I'm gonna do then is back in Hazel 2D, we've obviously got Hazel vendor mono. So what I'll do is going back to the root directory, we have our dependencies as well. So we're going to include mono as a dependency, and that's going to be in, let's bump it a little bit up before all the graphics related things. And it's going to be basically this /mono/include. So that's our include directory done. And then we'll also have library directory mono. And again, like we can kind of look at, I'm regretting closing it, but if we look at Hazel dev's dependencies, we can kind of see, you know, what we used here. Now we can probably copy it. So that's the mono library directory. So Hazel vendor mono lib, because it should be the same, right? Based on the build configuration as well. Now, this could cause an issue because there is no dist version, but the way we deal with that in Hazel dev actually is we just create a symbolic link, like a hard link, in our setup script that points dist to release. And so that way, like this will basically make it so that dist will, if for your binaries you happen to have exactly the same release and dist binaries, because we do for certain libraries, not for all, but for certain, then you can just symbolic link dist to point to release. And that way, like, this is all happy. So that's what we do. And that's probably what we'll do as well. But again, we're not really bothering with the dist config, making sure it works yet, because there's nothing to distribute yet. All right, that looks pretty good. That's obviously just library directory though. So now we need the actual library, which I will put, I mean, it looks like the only libraries we seem to be linking at the moment are like Vulkan related stuff, which is fine, but I'm going to probably put mono here. So I'll put like graphics related stuff kind of at the end because it tends to be a lot, and we'll just put mono over here. So mono is going to be library directory.mono. I'll have it with a lowercase m here. And then obviously not, well actually mono sgen, so this was like lib mono or something. We can take a look obviously over here. So inside lib and inside say debug or release, they're named the same. We have lib mono static sgen. So this is what I'm assuming we have to link. But again, I have no idea. Like we will see. So this should be fun. Okay, that's it. So basically what should happen now, guys, is if we rerun WinGen projects, then it should redo, this is the wrong repository. Then, that didn't really do anything. Oh, I have to include it, sorry, I forgot. So that was just us setting up the dependencies, but we also need to use them. So inside Hazel, we have, oh, this is just the workspace. So we include Hazel. So inside Hazel and the pre-make inside there, we have all these include directories. So again, I'll do this under ent. We'll have mono. Links, we don't need to worry about that, I think. And then for debug. Oh, okay. Yeah, we can just put it here, I think. So we can just make a links up here. Get rid of OpenShell, by the way. Oh, no, we're still using OpenShell. Sorry. Whoa, not so fast. Over here, we'll have library, and I have my dependencies open, and just mono, right? Because this will automatically now point to, you know, the right build configuration based on what we've generated. So I think library mono is all we really need to do, because there's no like specifically different one. The reason why we had to set up a different one here, by the way, is because they're named differently. This has a D on the end, this doesn't. And also they're not, I think they're all in the same directory. So it's just a bit of a different setup that Mono tends to provide compared to like Vulkan SDK. Okay, that's it. So we've got our main things were obviously the library directory, or sorry, the library link, right? So we actually link the library, and then obviously the include. But since we'll focus on linking a bit later, we're just going to deal with compiling to begin with. So the first thing I kind of want to do, obviously this stuff is in Hazel. We've included it in Hazel. Now it's all a static library, so this will actually be compiled into hazelnut.exe. But the main thing is when we don't actually have access to mono includes inside Hazelnut, just in Hazel, and that's deliberate. We don't really want to access that kind of stuff inside. Like, I don't want to give access to that stuff in Hazelnut. I just want to keep it segregated within the Hazel module. And again, if we really cared, which we do not, but if we really cared, we could even entirely segregate the whole scripting system to be its own DLL or its own module that we optionally compile. And that way, maybe if someone didn't want mono, they wanted to use like Lua for scripting, then they could, theoretically. But I don't care, and also C# is going to be the main scripting thing for Hazel. So this is, again, one of those things where you have to consider your scope, you have to consider what realistically you're going to use, and it's okay to make mandates and kind of, I guess, you know, go with a particular workflow. Like you have to do that, especially if you're, you know, if you're building a game engine yourself or in a small team. Like, you can't just pretend to accommodate every possible workflow. It's not going to work out. Be less generalist and be more, not necessarily specialist, but more particular. Question here, now that you're working for yourself for a while now, how have your work weeks changed in terms of how many hours you work and how much satisfaction you get from doing that work versus on a full-time job? I found that for me, it's much more satisfying to work on my own stuff than on the job, even if I'm doing the exact same stuff there. Yeah, I definitely find it more satisfying to work on Hazel than Frostbite. But I will say regarding work weeks, it's changed a lot. I've been working, I quit EA 2 years ago. Wow, it's been 2 years. No. 3 years. Damn. 3 years. Yeah, 3 years. Basically to the month almost. Wow. Just over 3 years ago, I quit EA. So, I can't believe it. I thought it was 2 years. That's so long ago, man. 3 years ago. So I've been working for myself for 3 years. It's changed a lot. It obviously started with me just working at home. Not doing much. Mostly just hanging out with my wife. And taking it easy for like a while after working full-time for EA for 4.5 years. But then I started obviously taking Hazel more seriously, spending more time building it, building the YouTube channel and stuff. And now obviously it's a bit different because now I work in an office and Peter works for me and Tim works for me as well. Peter's in Sweden, but Tim works for me in the office. So it's obviously a very different ball game. But also, also now I have a baby and almost a 6-month-old baby. Actually, yeah, tomorrow. She's gonna be 6 months tomorrow. Oh, that's great. So yeah, like it's. Oh, and tomorrow's my 2-year anniversary as a Twitch partner. Oh, cool. Thanks, Fake Lobster, for that reminder. I had no idea. But yeah, so like my life has obviously changed a lot. And like the amount of work I do and how I work has also changed a lot. I've definitely gotten better at working because it's kind of it's difficult to kind of work for yourself. I think being your own boss is a huge transition and it's very difficult to adjust to that. Because like somehow, even though I used to work at full time at EA and then do YouTube on the side, I kind of feel like I almost have less time to do YouTube now, which is weird. Well, not now, but like when I first quit EA and I was like, how is it that I don't have time to do anything? Like I thought I'd have so much time. If I could only quit my job, I'd have so much time to work on everything. But yeah, it's definitely difficult managing yourself. Okay. let's get back to this. But yeah, if you guys have more questions, feel free to ask them, because yeah, this is just the way these live streams tend to go. Like, I'm happy to answer questions. It doesn't just have to be full intense work, and we've obviously got mono compiling and hopefully linked in here as well, so it should be okay. Okay, but moving on, what I want to do is I'm going to make a new folder inside Hazel called scripting, and then inside here I'm going to make a folder called script engine. Now, I don't know if I'm necessarily going to copy Peter's design. It's not really Peter's design. I'm pretty sure I'm the one who made script engine initially inside Hazel, inside Big Hazel, but we've got a precompiled header in Hazel 2D, right? But we'll see if I end up copying his new stuff. But for now, all I'm going to do is set up a little script engine. This is going to be probably a static class, I think. Like, we don't have to make it a static class. That's the thing. We could make it initialized by the application. That actually might be a good thing. But the thing is, I don't think so. I think it makes sense to make script engine. Let's just make a default constructor. Nah, let's not worry about that. I think it makes sense to make script engine. We could delete the constructor, actually. I think it makes sense to make this, like, you know, init shutdown. I think it makes sense to make this static, because mono is something we're going to just boot up and shut down. Mono is essentially a C API. And whenever you have something like that, like, the reason why this is a class in the first place is mostly just for organization purposes. Like, this might as well just be a namespace, you know, and then we're kind of like, okay, cool, that's what it is, right? I just prefer putting things in classes. It doesn't add any overhead. It's just a personal preference, I guess. But again, the point of all of this is it is going to be static. And as a class, it obviously lets us also have private members if we want to. They'd obviously also have to be static, because all of this stuff is going to be static. But yeah, just a consideration. And the other good thing about a class is it lets us have static functions. Now, private functions. Now, these don't really need to exist either. And this is where I'm really going to think about whether or not I want this to work. Like, it's not really a big deal, but we could think about whether or not we want anything exposed in the header file, because we might as well just have all of this stuff here. And if it really is static, then obviously we could have a struct called like script engine data here, which contains everything, and just simply have like some kind of static pointer, or even just a member kind of thing. I wouldn't make it a member thing just because I might want to explicitly delete it and free that memory at a particular point, instead of just having it be for the lifetime of the app. But I don't know, maybe we'll do something like this and then just have this as like an interface, right? And then the cool thing about this is it also means that potentially we don't have to expose anything like into the header file. So for example, we might want to have a function called init mono, but that is something that we don't necessarily need to have here at all. We could just have it be, you know, in this file. And obviously, as long as it's accessing, if it's accessing stuff inside this struct, it also has access to all of it and everything is fine. And it can just be static to this file. So there's a lot of different ways you can kind of set this up. One of the reasons why I do like defining stuff here though, is because it avoids us having to have forward declarations if we want to use these in a particular order. So for example, if I wanted to have init, like I like to have init pretty high up in the file, because it's like the major function that is called kind of publicly, right? It's going to be called from the application class. But you can see in here, I can't call init mono unless it's forward declared. But I don't really like these forward declarations. So because of that, I kind of like making stuff here, even if I do have to label it private. So that's like just probably too much information for you guys about why I'm making some of the decisions I'm making. But to be honest, I don't have a rule book. I've never been a pedantic programmer, meaning like I don't care too much about the meta. I don't like to have conversations for 2 hours about whether or not something like should be, you know, should it be a member function or should it be static or should it be, no, I just like to write code. So that's just a little disclaimer, I guess, for those people who are pedantic about this stuff, to just get off my back and relax. Okay, so, and the other thing is, like, you know, it's okay to have opinions and differences, right? Like, I mean, people in chat really, like right now, are talking about CMake versus pre-make and why they might prefer one or the other. The answer is I don't care. And like, if you like CMake, use CMake. If you like pre-make, use pre-make. I rest my case. Because too many people like try and like, you know, suggest that something is better than the other thing, and you know, you need to use this, or I want to convince you to use this, and a lot of the times it just doesn't matter. That's all I'm saying. Okay. That's not to say that that's always bad. Like sometimes stuff is just better, right? And so you kind of want to obviously be like, hey man, did you know that this can make your life so much easier? Like that's obviously good as well. So I'm not saying like you guys should stop talking about CMake versus pre-make, even though I might be heavily implying it. Yeah, like it's fine to have differing opinions. Okay, so what I'm going to do here is I've just noticed that this include directory is actually going to be mono include mono, and that's obviously not my intention. I want this to already be there. Now, it might just be a compiler bug, but I'm just going to double check that, or a thing that, yeah, because this does seem to be include directory for mono, does seem to be vendor mono include, which should be, right, the include directory. So if we go to vendor, because I think we also have vendor included, don't we? I don't know if we do. But basically, if we go to Hazel vendor mono include, which is what we're including, then it's mono. Okay, so yeah, so it is correct. So it's just, yeah. I don't know why it's doing that. But mono, like for example, JIT, yeah, it's really not. Why is it not letting me? Let me just double check that path. Because it's been kind of annoying. Oh, I didn't regenerate the solution. Apparently. I thought I did. Maybe I didn't after I changed it. So let's go scripts, WinGen projects. Yeah, there we go. I hit this card. Okay, mono. Yeah, there we go. That's better. Okay, so let's go back to Peter's example, right? Because now I think I don't know how much he covered. Oh, well, yeah, loading assemblies and first steps. That's kind of what I want to take a look at. So the first thing we want to do is set the assembly part. Now, I obviously have reference code, which I'm going to bring up on my other monitor right now. Again, this stuff is part of Hazel, the full version of Hazel, which you guys can access on Patreon. But basically, yeah, I kind of know what I'm doing. I'm just going to have that here. If this will let me adjust my monitor a bit better, just to make life a bit easier. But also Peter's guide is obviously good, so I might actually go 50-50. I'm going to have Peter's guide on half of my second monitor, and then Hazel Dev on the other half. Beautiful. All right. Let's begin. So the first thing we want to do in init mono is we want to call mono set assemblies path, and we're going to set it to mono/lib. Now, this is important. Mono/lib is going to be a directory that's relative to our working directory. Now, we've determined that we want libmono 4.5. So I'm going to copy 4.5, right? And then I'm going to go into our working directory, which we should know for hazelnut, right, is going to be, obviously, when we run it through the debugger, it's going to be the location of this VCX, the directory that contains the VCX proj. So over here, since we're setting this to be monolib, I'm going to make a directory called mono, a directory called lib, and paste in 4.5 into here. I believe that is the correct setup. So that's what we're going to do. Now, obviously, we need to call this function. Now, using a visual assist, I can just hopefully search for this, and maybe it will search the include directories. No, that would have been useful. Or I could try Alt-G that. No, okay. Well, I can cheat and use Hazel Dev to see that it's in metadata assembly. So metadata, I've just included JIT for fun. I don't really know why yet. Just because I know it was included in Hazel Dev, but metadata assembly. Okay, awesome. So monoset assemblies path has now been set. And And again, this stuff is in the first steps inside Peter's guide. So shout out to Peter's guide. Peter, you should put some ads on this. Cash in. Yeah, and see, Peter's even done some good work here because he's even said what happens if you don't provide this path, or if it can't find it or whatever. It'll try and load MS core lib, and you can see it won't be able to. So that's kind of important, and that's also, yeah. So the next thing is we're going to do monojit init. So there's the set assemblies path. There's the monojit init MyScript runtime, which in Hazel monojit init, we call it the Hazel JIT runtime apparently. Yeah, this is kind of what we're going to copy, and then we create an app domain. So I'm just going to copy like this, and I'll kind of explain some of this, and Peter probably does a nice job of explaining it as well, so I probably don't really need to explain much of it, unless you guys want the details. But basically, if we copy the rest of... Oh no, I did that thing where I hit Control X and then Control C, so it pasted a blank line. Let me get back to Peter's code, and we will copy this stuff. So mono domain, root domain, and then we'll call this like Hazel JIT. I guess we'll call it the same thing, Hazel JIT runtime. That's what it's called in Hazel Dev. So if root domain is null pointer, then obviously we might have to handle something, which actually this in Hazel is just an assert. So we could obviously do it like a hz core. We don't have a verify apparently, but we'll do an hz core assert root domain, right? So we'll just make sure that we have this. That'll be the equivalent of that. And then we'll also store it somewhere. So s root domain. So this is where I'm going to make ns data. So init is going to allocate this script engine data block for us, and shutdown's going to delete it. Yep, I'm using raw pointers. Fight me. And then we're going to just do s data root domain like that. And this is going to obviously be a mono domain, root domain. And we're going to initialize it, by the way, to just be null pointer. So that way, yeah, just in case we never call this, we can assert it elsewhere. But init, by the way, just to give you guys the big picture as well, we're probably going to initialize the script engine inside application. So you can see we did renderer init here. I think we're also going to do script engine init here. Okay, at least for now. Like we might move it around later. It's kind of difficult because we have no idea. Like we're gonna restructure a lot of the application architecture anyway when it comes to adding Vulkan, right? So yeah. Cherno, so are your project names all going to be nut names from now on? No. I mean, Hazel, again, it's not hazelnut, it's Hazel. It's just hazelnut is the editor for whatever reason. Don't know why, couldn't tell you. Walnut is, yeah, walnut, I wanted to make a nut. But no, I don't know what the next one's going to be. Actually, well, we have, you guys can't see it, but we have the Cherno logo, which is a C. We have Hazel, which is an H, so it's kind of spelling out Cherno. So we need a new project name. It should probably start with an E. So that's going to probably be the next thing I create. It's going to start with E. Maybe it's going to be a game. Maybe it's going to be the Hazel 2D game that we make. Oof, that would be fun. We'll see. Okay, so S app domain. So the next thing is going to be create app domain, which returns a mono domain. So we have a root domain, we have an app domain. So S data app domain, and then my app domain. Let's consult with Hazel. What is this called? Mono domain create app domain. I don't even see that code here. Okay, we do it when we load the core assembly. Oh, because that's right. So Hazel script runtime is what it's called. New script domain, Hazel script runtime. Okay, so I'll call it that for now. Doug Tensor, thank you for resubscribing because of the nut naming fetish. Keep it up, Cherno. Thank you, appreciate the support. Yeah, so we'll call it. We'll do that, and then we'll set the domain, I guess, to be that. Now, Peter did have some notes there, so I kind of want to make sure I understand this, right? So let's go kind of from here. So once we've done that, we have to call monojit initial to start the runtime, but you may notice there's actually another function, monojit init version. What's the difference? Difference has to do with what version of the runtime we use. So by using the first function, we're telling mono to use the runtime version referenced by the first assembly that we load. Ah, interesting. Okay, that's cool. I would not have guessed that, meaning it will automatically detect it. If we use a second function, we specified the exact version of the runtime we want. Okay, good to know. From my experimentation, what function we use doesn't have much of an effect. Well, yes, like the JIT version, right? And it's generally speaking safer to let mono automatically pick the runtime version. Yeah, that makes sense. We must make sure to give this function a string when calling it. The string essentially represents the name of the runtime. When calling this function, we get a mono domain pointer. It's important that we store that pointer since we have to manually clean it up later on. Yep. The interesting thing is that mono actually stores this pointer internally as well. And according to the mono developers, it doesn't really make sense that we have to keep track of that pointer as well. I like that you included this note, Peter. You're like, by the way, mono is a pile of garbage. Okay, so that's the basics of initializing mono runtime. Naturally, as we continue to develop our scripting engine further, the initialization process will get more complex, blah, 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 but we'll cover that. Yep. Now, we're not quite done. We have to load our C# assembly and start running code. Well, to do that, we have to have an app domain, which you've linked to something else. Well, yeah, this is a general C# app domain. So mono makes it trivially easy to create a new app domain. All we have to do is call mono domain create app domain and give our app domain a name. Remember to store the mono domain pointer returned by this function somewhere. We'll need it later on. Yep. The process will become slightly more complicated in the future. Yeah, I can see that because I've got Hazel, the big version of Hazel over here. But for now, we'll just modify our initialization function to look like this, which we've done already. You may wonder what the second parameter of mono is. Well, it allows us to pass a path to a configuration file. Interesting. We won't be needing this, so we can simply pass null pointer. Once we've got our app domain, mono domain pointer, we have to set our new app domain to be the current app domain. We can do this by calling mono domain set and pass our domain. Yep, that's good. Now that we have created a domain, we can finally start working towards running C# code from C++. Okay, all we have to do now is load a C# assembly, which we'll cover in the next section. Brilliant. So yeah, let's make sure this is all good. I think it is for now. Again, we're just creating an app domain with no configuration file. Storing the root domain pointer. Obviously, we'll have to unload that, I'm imagining, in like the shutdown mono function, which we don't have yet, but I might just add that. And the reason why some of this stuff is going to be important, by the way, is because we're literally going to have to reload assemblies, obviously, on the fly. And that requires like releasing app domains after they're like not in use or whatever. And then obviously reloading them and stuff. So it's important to kind of, yeah, that's going to be a tough process. I'm not really looking forward to that. And I might just steal it from Hazel, to be honest, because I don't know if I want to waste time on that if it's already been done. But I remember that took a while. I mean, when I first, before Peter worked on the scripting engine back in the day, when I first had to tackle, like 2 years ago or whatever, reloading assemblies, that took me like a week or something. Like, that was a lot of work. Oh, and Peter's saying he stole it from the old scripting engine because my approach didn't work. Yeah, I don't know what's going on with it. It's hard. It's hard. For whatever reason, it's hard to do. Okay, so now that we've got all of this, we can actually load an assembly into this app domain. And that's obviously this next thing. So what Peter's going to do is create a C# project, which is going to be a dynamic link library. And then we're going to add some C# code called C# testing, which he's done here. By the way, Peter, I was reading this and I saw a bug. Your printing here doesn't actually print the float because you forgot the parameter. So just a heads up. I was reading this earlier. Like last week or something, and I was like, huh, that's funny. Unreliable guide confirmed. It's going in your performance review, Peter. This beautiful open source piece of information that you published, which no one asked you to do, is missing stuff, so sorry. That reminds me of like those games you play where like you can lose score. So it's kind of like, you know what I mean? Like imagine if in basketball, you're playing basketball and if you like take the shot but you miss, you like lose 2 points. So it's like, it's better not to take the shot than it is, because you might lose score. That's what this reminds me of. It's like, Peter did some work. Peter did some nice work on his own accord, but unfortunately he messed it up, so he loses. That actually, okay, guys, story time. True story. I had this subject in university called database programming, and the person, like, we had so many issues with the person running that course, but basically the way that they marked the exam is like, okay, so 70% of the class failed. We're going to interrupt this for a little story time, right? I'm looking very contrasty. I don't know what's up with the camera and stuff. Is this fine? What do you guys think of the colors? They look fine. Looks kind of intense to me. Oh, okay. Thanks, Vague Lobster, for that little adjustment. I'll fix that in a minute. Little story time break. So, database programming. The year is 2016, I believe. Was it 2016? Maybe it was 2014. I don't know if it was 2014 or 2016. But anyway, it was one of those 2 years. Definitely was not 2015, because that's the year that I was interning at EA. Might make it a bit. I don't know if that'll help. So basically database programming, and we had this like test. We had this like kind of exam. It wasn't really like an exam, like an end of semester exam, but we were sitting in the lecture theater and we were doing basically an exam, right? And this was like a hurdle exam, which means that if you don't pass it, like you can't pass the unit, they called subjects units. We can't pass the unit without passing this assignment, basically, which was like a written paper. 70% of the class did not pass it. Because the way that this person marked this, and by that extension, 70% of the students failed the unit, right? Because the way that this person marked it is a question, you'd get an entire page to answer a question. This was related to databases and stuff. And like really, really annoying database stuff. So like transactions and like probably some Java libraries. Like there's one called like, so it starts with like the letter H, or I don't know, it's weird. I don't remember this stuff because it's useless, but basically entire page to answer the question. It's worth 10 marks. Yeah, I think it was probably Hibernate. Yeah, something like that, maybe. But basically, entire page to answer the question is worth 10 marks. And you read your answer and you're like, how did I get 0 marks for this 10-mark question? And the reason why was because the way this person marked is if you mentioned something that was not correct, or you mentioned something in your answer that they deemed wasn't 100% relevant to the question. So you know how when you're writing, a 1-page answer, you might mention some stuff that you know that might not be 100% relevant to the question, but it also shows what you know. And also you do generally, I'm not saying you don't answer the question at all, you just go on a longer explanation and you explain a few more things. So anytime you do that, or you get something wrong, -5 marks. So if you do two little issues in your 1-page response, that's 0. That's down from 10 marks to 0 for that question. And there were maybe 12 of those questions or so in the thing. So get this, guys. So the kind of person in charge of this course, not the subject, but the course in the university, after hearing that 70% of the students failed this unit, right, swooped in and said to the lecturer, to the person who was leading or convening this unit of study, said to them, I'm sorry, you can't fail 70% of the class. You can't fail 70% in the class. Like, if 70% of your class is failing, then clearly you are doing something wrong. Like, that's impossible. And so what ended up happening was we all got called in one by one into this person's office. One by one, we sat down. Like, it was funny. It was really funny, right? Because there were like, what? I don't know, at least 50 people probably doing this subject. So there's a line of like 70%, I guess, of 50, however much that is, like 35 or whatever people. There's this line of like 30 something people on like the 4th floor of this building, all the way going to this person's office, who get called in one by one, sat down, and then the lecturer, the person in charge of the unit, explains to them what they did wrong and how dare they. And then you say, yes, I'm sorry, forgive me, please, I'm sorry, I tried. And then they ask you the question, you're like, okay, so explain it. And then you kind of explain it, and then they're like, okay, fine, good enough, passed. So what's funny is, guys, I'm a good student. Like, I don't need to, I don't know if I want to reveal the university I went to, but I will somewhat censor this. It's gonna be hard to see this, but look at this. I don't think I've ever shown anyone this. Well, on stream at least. I got this prize. You know what prize this is? This is the prize for the highest achieving graduate in this entire course. Now, guys, I don't know how I got this. I'm gonna be completely honest with you. I don't know how this happened. The class must have been really bad because I did not even get close to like 100%. And this is across the whole course, right? I did not get 100%. I think I got maybe an average of 90. I mean, I was a high distinction average student, but I think I got about 90. I don't know how. And so what happened was, like, and I swear, you know, I'm not one of those people who is actually like really smart and is like being all like, oh yeah, I guess I'm not that smart. Like, I am serious when I say I do not deserve this at all. Like, I'm not saying that to be modest. I'm saying that because it's factual. But anyway, wait, I want to see if I can do a little, let me see if I can do a little zoom in. Oh, no, you know what? No, why am I doing that? I'll just do this. Hold on. I'm just trying to, All right, there it is. Proof. I mean, I may have just printed this certificate myself, but that'd be pretty low, wouldn't it? All right, anyway. So the reason why I brought this up, by the way, not to brag or anything, but, oh, and that's a whole story in and of itself, because I was, like, the university gave me a check for $1,000 for this prize, and I was also taken to lunch with the people who established this foundation, because I think their son died, unfortunately, from cancer, and they established a foundation, like, in his name, and that's, like, that foundation is what gave me, like, the $1,000 and this certificate, and I'm sitting there at lunch being like, and they're probably thinking they're talking to, like, the next, I don't know, Mark Zuckerberg, or, like, someone who's actually smart, and I'm like, yes, I study, I like exams. Anyway, I felt so, I don't know, I just felt kind of bad being there, because I'm like, why am I, like, I just don't understand how it happened. But anyway, the reason why I brought this up, guys, is because to prove the fact that I was a good student in university. I got a high distinction average, but you know what I got for database programming for that unit? I got a 50. I got a pass. Yeah? I got a pass, which is like, I got a 50 out of 100. If you get below a 50, you don't pass it, unless you get a conceded pass, which I think goes down to 45. But I got a 50. And I know it was 2014. You know how I know it was 2014? Because at the end of 2014, I was like interviewing to get an internship at EA. And I remember that stupid database programming unit. I was worried that, because I had to give them my academic record, like, to EA, so I guess they'd look at it or whatever. Not that they cared. Like, honestly, I don't think they cared, but it was just a formality. And I remember I was worried, because I'm like, dude, they're gonna see that pass, and they're gonna be like, this guy's a loser, like, because every other subject that semester, I did 3 other subjects, I got a high distinction, but for that one, it was a pass. And I was like, dude, they're going to see that and they're going to be like, sorry, Cherno, we can't hire you. Like, who gets a pass in like this? Like that, you clearly suck. But I don't think they cared. And I remember, oh, what a thing to be worried about though. But anyway, story time with Cherno has concluded. The one pass, the 150 I got in my entire degree. And still, guys, with that 50, I got this. That's why I don't understand it. There must have been a bug. There must have been a bug in the computer system for me to get this award. I actually don't know how I got it. Again, being fully serious. All right, anyway, mono. Back to mono. Yeah, Peter, I'm sure you are glad that I didn't get your academic records before I hired you. All right. So Peter's going to teach us how to write some C# code, whilst also failing to write proper C# code. But then we can figure out how to actually load this. So this is going to be interesting. I'm probably going to copy most of this. I'm not actually going to, again, I want to teach you guys this, obviously, in a way that involves me not digging into proprietary source code. I would love it if all of you guys would like pledge on Patreon and support the project and download Hazel and take a look at it. I'm going to just suggest you all do that now, because obviously your support is what helps us actually build Hazel and also this game engine series in turn, right? So you should do that, yes. But I also don't want to necessarily force people who might not be able to afford it or whatever to have to dig into proprietary code. Well, it's not really proprietary code. It's kind of half open source, right? But to have to like, you know, subscribe on Patreon or whatever to get access to it. So that's why I'm trying my best to kind of build it from the information we have here and then modify it, all right? So that's why I'm going to, again, just take Peter's code, which is publicly available here, and then try and implement it. And then we will obviously sort it out and make it a little bit more robust. Sorry, I didn't mean it that way. But we'll make it a little bit more, not really robust, but more suited for an actual game engine, you know, instead of just obviously a hello world style example, which is what we've got over here. Okay, cool. And there's a bunch of other information Peter's added, which we might actually take a look. Why mono and not new Coursera? Because Peter explains why inside, I think, the introduction, maybe, or about mono. Yeah, why not use .NET Core version? So there's a bunch of information there. I'm not going to bother explaining all of that. But mono just happens to be better suited for embedded, for embedding actually the runtime into an application, which is how we're using it, and it makes more sense for a game engine. Is basically the short answer. So we have we have read bytes, which is going to obviously take in a file path and just probably, yeah, return a char pointer here. Now, I don't like using char unless it's for an actual character, so I might make this a uint8t. And this buffer, I can probably see why Peter may have made it like this. I think it's because, so when we use read and when we kind of set up a IF stream, I think by default this is a char. So you can see it's a basic IF stream of char. But again, char and uint8t should be the same thing. Oh, sorry, actually uint is unsigned char. int8t is not unsigned char. So I can kind of see why he set it up like that. I don't really like the idea of using that kind of stuff. So we'll see if we can just use like uint8t, which is kind of my default byte format, right? But again, I don't know if we'll be allowed to. Yeah, because see, this actually needs to be a char. So we might just stick with, and I think if we cast, I mean, this should be the same type, right? Or is it really upset still? int8t is incompatible with char, but isn't int8t a char? Or are they built-in types now? So, oh, is this a different type now? Color me surprised. Okay, we can use char. I mean, it's the same size, so it doesn't matter. But I guess we can just use char because that's what the IF stream uses. If we you know, used our own API for this kind of stuff, like that would revolve around the Windows API basically, then we would probably, I would probably avoid using char, just because I like to use, you know, types with the size in them. But yeah, it'll be okay for this. So this is going to obviously take in a file path, which is going to be our DLL. And it's going to load it, at which point we're going to, well, actually, no, sorry. Load C# assembly is a function which uses this read bytes function, which is up here, to load our assembly path and get its file size, to which then we can provide it to mono as an image, and then we get a mono assembly load from full. And then we close the image. So you kind of get this, you open this kind of image, you get the data from it, you give it to the assembly, you close the image, you delete the file data, and then now you have a mono assembly pointer, which is going to be like important because that's going to, the mono assembly is going to kind of be where we retrieve all of our information from. And by information, I mean like metadata and, methods, functions, all of that kind of stuff that we're going to need to use. And so what we'll do is there's a bunch of different types here, or a bunch of different like things here that we can talk about. But I think one of the best things to do here is probably take a look at what we've actually loaded. So print assembly types. And this is one of the things that I really want to kind of add into Hazel, into this Hazel 2D. I want to kind of try and work in as much debugging stuff and as many like tools as I can. One of my mistakes, I would say, when writing mono kind of C# scripting engine for Hazel in its first iteration 2 years ago, was I didn't really spend enough time providing tools to actually inspect what was in the assembly. Now, we got away with it and it wasn't that necessary, but I think it would probably have resulted in a more robust system if we at least had some tools to be like, hey, what does this assembly contain? Because for one of the things that I didn't really like is for ages until Peter added it, somewhat recently I feel, you had to basically, when you added your script component into your entity, you had to basically manually type like, game.class name to like as a string, to connect it to something, and it would test to see if that was there. It'd be much better to get a list of all the possible classes that we already have in the assembly, and then maybe match it with that, or give you a drop down, or something like that, right? And we have that in Hazel now, which is very, very, very useful, right? So I want to spend a little bit more time being able to read data from assemblies, and also that's going to verify, it's going to help us make sure that we're actually loading stuff correctly and give us, let us see what we actually have access to. Vague Lobster, by the way, I see that C there, because he mentioned that earlier. Okay, so, yeah, so that's why what I wanted to do, and I don't think I pasted it in, but I want to basically copy this, right? This print assembly types. Let's copy that and we'll paste it in here. So this is becoming a bit of a mess. We'll sort it out in a minute. But basically what this is going to do is go through, and I think it's going to print every namespace and name that we actually have inside the assembly. So what we're going to do is we're going to run all of this now. We're going to make a C# assembly called Hazel Script Core, which is going to be our core library for all of our C# scripting. So this is like the library that comes with Hazel, and it's going to contain obviously all the types, like all the math types, like vector 2, vector 3, vector 4, as well as obviously like the entity type and the whole Hazel side of the C# API. We're going to make that in a minute. We're going to load it here, and we're going to dump all of the types, and that's going to be kind of like our step one to actually, getting all this stuff up and running, because that will obviously test mono being loaded, and then we can do some kind of reflection metadata scraping before we actually move on to executing functions using the virtual machine, which I don't know, we might do today. I probably got like another hour because I did start a bit early today, but yeah, we'll see. Okay, so to make that happen, here's what I want to do. So we've got init mono, print assembly types. Yeah, so what I'll do is I'll move all this stuff up here. And then once mono has been initialized, which is over here, what I'm going to do here, I think, is move this maybe. I'm just going to write this down. I'm going to load a C# assembly. So we're going to load an assembly. It's going to be called Hazel Script Core.dll. Again, I will, and then yeah, that's all we need. We'll have to provide a path for that probably in a minute. That'll just be relative to a working directory, but we'll see. Let's kind of store that here. So it's going to be a mono assembly, and we're going to call this core assembly. equals null pointer. So S data core assembly equals load C# assembly. And now that we've got that, we can print assembly types, and that's really it. Now we probably should release the assembly and deal with all of that stuff, but we don't really care about that, let's be honest. We just want to test it out first. So yeah, so at the moment it's going to obviously try and load this assembly which doesn't exist. So let's create it. So we're obviously going to create it using Premake, right? Otherwise, if you weren't using Premake, you're just using Visual Studio, you can just go right click, add new project, and then we want to basically create this class library in C#, right? But the way that's going to look in the Premake is if we pop over into series scripting, which is my folder for this repository, we're going to go into Hazel and we're going to copy the Premake 5.lua. We're going to go out into the root repository and make this folder called Hazel script core. We're going to dump the Premake file into it. I want to quickly see. Yeah, I mean, so with the C++ projects, right, if you look at our structure, we have a source folder. For C# though, I think we have a source folder. We don't have a source folder, we have a source folder. If you catch my drift, meaning it's called that, right? Yeah, that's just how it works, and I'm gonna stick to that convention because again, C# is all like proper, more like English thing, and C++ is more of a, yeah, I don't know why. To be honest, I'd probably rename this source to just be source, you know, because why would you, don't need to take weird like conventions or whatever, but I think this is also the default generated kind of folder if you make a project through Visual Studio or whatever. But basically this Premake 5.lua file, we're going to take inspiration, aka copy, the one that is inside the Premake inside the big version of Hazel. So if we go down to script core, which is here, you can kind of see how we've made that project inside Hazel, right? So the project name obviously is going to be Hazel script core. Location, now we don't need a location, I believe, because we're already there, because this is actually a main Premake file that includes all the projects, whereas here we have one per project, so we don't need to do that. So kind is going to be a shared library instead of a static library, because it's going to be a DLL, and the language is going to be C#. .NET Framework we've listed as 4.7.2, but we'll be using 4.5 apparently, I guess. I don't know, like 4.5 of the libraries we're linking, but I think that the .NET Framework version we'll be using is 4.7.2. I don't know why it's not 4.8. I don't know why it's this. Peter, you can help people and me discover why. But yeah, don't know. I'm glad you guys are excited that I'm doing scripting. So am I. This is fun and very necessary to do. And it's gonna, yeah, enable so much stuff. But it's also really straightforward, like, as you'll see, hopefully. Once you've done it, I mean, I did it the first time like 2 years ago, and I've been working with it for a while. Once you know how it works, it's easy, like most things, I guess, in programming. Okay, so target directory and object directory, so the intermediate directory. So yeah, so this is set to workspace directory bin. You can see here we actually build it into Hazelnut resources scripts and intermediates. I'm gonna stick to this as well. The reason why is, and I don't know why we're using workspace location here. I guess that's important, so we might retain it just because, again, this is inside its own folder, whereas here, this Premake file is inside the root of the repository. So that's why it has a location. That's why some of this stuff differs. But I'm going to just add in this here, and then we're also going to have intermediates here. The reason why is because, guys, this isn't like some kind of binary we're building, like an exe. This is ultimately a resource or like an asset that we use. Now, script core is the core library. That's why we're putting it into Hazelnut resources, which is where all of this important stuff is. Right inside our resources directory, we have stuff that well, actually we've only got icons, lol. But like for example, that's where all of our shaders are. At the moment, our assets contain our shaders, but the way it's kind of split up inside Hazel is we have the concept of projects. And since we have projects, God, I remember adding projects. That was a nightmare. Peter, do you remember when we added projects? Like, I remember that was like, oh, that was me going through all the engine being like, what a mess, basically. But basically, Like Hazelnut, like everything that's core to the engine stays in Hazelnut resources, which we can also share with the runtime. So we have runtime/resources as well. Same exact thing, except obviously you don't need editor icons and editor only resources for the runtime. And then the project, meanwhile, contains an assets directory. And that assets directory are obviously like assets that are used by your game, which would include the game scripts, right? The built like game script DLL. But this is the Hazel core DLL. And because it's the Hazel core DLL, it belongs in kind of resources. So that's why we're putting it there. And so basically in resources scripts, this should make the directories. We should see it pop up over here. And this will be kind of used. This will be loaded by core Hazel and all that stuff. And not really part of obviously a specific project because this is the core library. Okay, and then we obviously have our files. So we include apparently these things. So let's get rid of the PCH and whatever. Might get rid of like the rest of this stuff because I'll probably copy it from here. Yeah, let's actually copy it from here. So files, I don't think we need project name because we're already there. I think it's just source, right? So this is a good idea probably to go into like Hazel and well, yeah, Hazel or Hazelnut and take a look at its pre-make and just to see, oh no, okay, so it does go to workspace. Oh no, yeah, so see it's relative to this. Yep, that's fine. So source properties, and then for debug, optimize off symbols default. Yeah, we'll just keep everything as Peter's made it. Oh, I don't know, maybe I made this. I feel like Peter's probably modified it. But yeah, that's it. So now we have Hazel script core as an actual pre-make file. And then, so what we can do is inside source, we can make a text document called main.cs, which is going to be our kind of test, right? And then if I go out into the pre-make file in the root of the repository, we're just going to include Hazel script core so that we obviously build that pre-make file. Now this would probably be a good place to kind of group it, like to add a group for it. Now inside Hazel, where does it live at the moment? Inside Hazel, it lives inside core, right? So this is what I want to do is I'm now going to make a new group. Now that we have two items here. Called core. And core, so we've got dependencies, that's cool. We've got core now, which is going to just include Hazel and Hazel script core. And then like sandbox and Hazelnut, like again, Hazelnut we have under tools. So I guess I might as well just make this look a bit prettier. So we'll put Hazelnut under tools and then sandbox. Sandbox, I guess, will be kind of under maybe MISC for now. And I'll put it last. We don't really need to like have these after everything. I just do that to keep it a bit clean because obviously we override it here. But let's keep it kind of a bit nice, more nicely organized. So back here we'll run generate projects to regenerate that, reload, and we should have those nice groups here. Right, so we have core up here, Hazel and Hazel script core are now here. The source, there's our main C# file. So now we can go ahead and actually start creating stuff. So if I say public class like main or whatever, maybe we'll using namespace, using system. And I don't know, we could make like a public, should we have like a, yeah, okay. We can probably try, what's a good thing to do? Maybe call a static function first? Or we could try and make a class instance, you know? I kind of want to maybe have a finalizer as well. Or a destructor. I don't know. Just to kind of test that out. We'll see. I don't know if we'll get into object-oriented programming stuff here, that's all. You haven't tried static stuff, really? But we are calling static stuff. Because we obviously support static stuff. As in, that's how we link all of our internal calls, mostly. They're all static. But anyway, so public void print message. We'll print hello world from C#. And then we're also going to have a print custom message. So note these are not static, right? These functions are not static, so we're going to have to make an instance of main. So that's going to be the challenge. And then we're also going to pass a string, which we will print. So maybe we'll say something like, C# says, right? So we can print some stuff from C#. And then I also want to have some kind of float variable get set, right? So this property will probably generate like a getter and setter function, I guess. So let's, yeah, that's it. So let's try and build this. This should now go into, as you can see where it's gone here. It's gone into Hazel resources scripts and script core as we kind of told it to. So here it is, scripts, and then Hazel script core. So relative to our working directory, which is hazelnut, it's resources/scripts/Hazel script core. So going back to our script engine, closing this, we have resources, scripts, and then I always capitalize the C apparently, and then Hazel script core. Okay, so this is yeah, pretty straightforward. What's next, guys? And obviously we're using, like, we're gonna have to load MS Core Lib from this to use system.console.writeline, right? So that's important. And you can also see, like, we build debug and release into the same directory. So whatever we built last overwrites it. So if I switch configuration to release and build this in release, it's going to build, like, it's going to override this DLL. So we don't kind of split them up here because it doesn't really matter too much. Okay, so that's it. So if we load this, we'll hopefully get some types being printed. Obviously, the only type we're printing at the moment, like, we're printing types. So we're just going to get main, like, and it's not even in a namespace. Let's add it into a namespace called Hazel, because this is Hazel script core, and then we'll call it main. So let's build that. Oh, I did Control-Shift-B, which is what I usually do when I'm working on stuff, but not here. Yeah, and obviously, because we selected, if we actually look at the properties for this, oof, let's ignore that. If we look at the properties for this, then you can see that we've set this to be a class library, which is why it builds into a DLL, not an exe. And we obviously did that in the pre-make, and it's using .NET Framework 4.7.2, which is also what we specified in pre-make. And the build output is obviously over here as well. So this can be useful for, like, debugging, I guess, your pre-make scripts. But yeah. All right, so we got a worrying amount of linking errors there, I think, which I kind of wanted to not look at. So let's build it again and see what we get. So we've got all of this stuff unresolved, and this all seems to be somewhat networking related stuff inside the Windows API. Possibly the Windows API? No, Mono. Oh, okay, networking stuff from Mono. So Mono Win32 socket bind. Huh. What does this use? Unresolved simple imp bind and get sock name. What library is that using? Mono W32 socket bind. Let's quickly open up Mono. What was it? W32 socket bind. Bind. What is this bind function? WinSock. Oh, this is WinSock. Mono metadata Win32 socket. We could disable sockets. But why? Oh, I think I know why. I think WinSock is a different WinSock. I believe WinSock might be a different library. Yeah. So WSOC32 lib or something? People are... what's the actual function that we tried to call here? Bind, right? Is that what I found? So bind... Because I think it called this bind function, but that does not look like a Windows API function, but it is, it's in WinSock. That's so weird, man. That's so annoying. Ah. Okay, so by the way, just so you guys know, the way I'm kind of debugging this is, if you take a look at, like, I googled Win32 bind, right? This can be difficult to debug as well, but what I'm looking for is basically the Microsoft Docs, right? So if I go into Docs here, you can see that this is the bind function, right? And it's in winsock.h. And the thing that I'm looking for is at the very bottom, usually, they've got the library that includes it. So you can see it's ws2 32.lib. So this we need to link, right? I'm not sure, like, Peter, are you linking this in Hazel? I'm not sure, but basically, and yes, there's also Winsock 2 and Winsock, which can be annoying. If you've built a lot of Windows stuff, you probably know the annoyances between some things, including this. This is the older one, and the Winsock 2, which is what you should include. That can be annoying as well. But let's try linking this, and we'll see if that helps. We don't, because it's dynamic. Yes, that makes sense. Yep. Okay, excellent. Because I was slightly worried there, because I'm like, why? But that's okay. So we'll go back to the pre-make. For Hazel. So serious scripting. So Hazel, pre-make, and then, well, actually, and obviously this will differ if you're including it for Windows or for other platforms. But if we go back to dependencies, I want to kind of make a, what is this, Lua? Like, what's a comment? Windows only. So these are, well, I'll just say Windows. These are going to be like the Windows dependencies. And then obviously this is what we want to include. Now you don't need to specify a directory or anything. I'm just going to add a little, I don't even know if I should add it here, to be completely honest, because it's just that. I might just say Winsock like that. I guess that would make more sense than what the heck is that. So if we go back to here, under library directory mono, we'll also have Winsock. Now, again, I should probably do the honorable thing and put this under system Windows. So in system Windows, I'm going to have a link. So I don't know why we have an empty define there, but because it should probably say hz Windows or whatever. That's weird. Why is that not there? Whatever. But whatever. I'll have links and then I'll put library Winsock. Okay. So now if we regenerate that, got a lot of stuff open. Then I'll reload that. Let's try build again. Okay, so much better, much less. So now it's time set event. Inside function start profiler timer event. So let's go back to mono. Start profiler timer event. By the way, Visual Assist comes in handy here. As you can see, what I'm doing is just Alt-Shift-S, and it's just letting me search the whole like solution for all of the symbols, and that's how I'm easily finding these functions. And then I can see time set event. I think that was the one that was undefined as an example. I mean, probably all of them, like time begin period as well, obviously, everything related to time. So I'm just seeing what on earth that's included in. So again, this does look like a Win API thing. So if we go back to here, we'll just do Win32 time set event, go to what was it called? MS Developer Network? MSDN, that's what I'm thinking of. And you can see it's in WinMM. So again, and what is this for? What's WinMM? I'm just trying to give it a better name than WinMM, but I guess we can call it WinMM. I don't know what that is. Yeah, so going back here to dependencies. What's going on? Why is nothing working? Visual Studio is not working. Okay, this file is. All right, loading dependencies again. Hey. Okay, WinMM. WinMM. I don't know what WinMM is. Like, as in, if there's like what it stands for or whatever, but I would have added it here. Maybe I'll quickly Google it. Yeah, what is WinMM? Windows Multimedia API. Okay. Maybe I'll write it like that then. Or maybe that's bad, I don't know. Nah, I think that's correct. Okay, cool. Right, so Windows matchmaking, that's funny. Okay, so WinMM, back in pre-make then, in our actual pre-make thing, under Windows. What? Why did it disappear? Maybe because I was fooling around with with the control, because my control key wasn't working in dependencies or whatever. Control Z didn't work, so I probably just yeah. So WinSock, WinMM. Get rid of that. All right, reload. Is that it? Build. Ugh, okay, probably last one, maybe. Okay, no, well, get file version. Why is that not just part of Windows? Get file version info size W. Well, that's clearly a Windows thing. Get file version info size. Doesn't matter A or W. It's just ASCII or wide. So that's in version.lib. Damn, that's an interesting one. So obviously, yeah, the dynamic library loads all these for you, but we have to link them in, which, like, I don't know, I don't really, well, yeah, I guess it's fine to just link them statically. See, yeah, I don't know. It's kind of nice to have them linked dynamically as well, maybe. But yeah, it's probably okay to set them up like this. So dependencies is corrupted as usual. Seriously. Like, that's one of the most that's one of the other frustrating things about Visual Studios. For some reason, just that dependencies thing is always so weird. So version, I'll just say Win version, because it's the Windows version thing. And I think there was another one we could probably look at, which is ver query value. That might be in the same one. And then bcrypt gen random. Which does not sound like it would be in version. Bcrypt. Bcrypt. Okay, let's see if that works. Okay, it's building. Awesome. So now we've built an exe with all of those statically linked things. So now our binary is nice and fat. Obviously, it only links in functions that it actually uses, so it's not like it's the whole thing. But if we go into our script engine, so what should happen now is obviously we're calling init from application. So application CPP calls script engine init. Script engine init will call init mono, and then init mono is going to, down here, is going to basically do all of this stuff, right? So we can put a breakpoint here, hit F5. That way we can kind of you know, go through it line by line and make sure everything's working. We could just let it run, but this is probably a bit more fun. So we try and make a root domain, and that crashes. Okay, so mscallib was not found. So apparently this did not work. Mono set assembly's path. Weird, considering I'm pretty sure that I put it into hazelnut mono lib, and then we have 4.5. So let's take a quick look at Hazel devs directory. So we have hazelnut mono lib, and then mono. So see, these are the little things of why it's nice to have Hazel dev or big version of Hazel, just because I wouldn't have known that, you know, but it has to be inside mono, and then we have like this here, and we have 4.7.2 API. I don't know if we need that. I think that's just like some other thing, but yeah, like it's, you know, like it's just nice. So let's see if that works. Okay, so that worked. We've initialized it. And we seem to have a valid root domain. I unfortunately, what did I even do? I added a space. Brilliant. So that's there. Now, if we continue going through this, we set the root domain. We try and create an app domain, which seems to have worked as well. The only problem is, I don't know why, but this, like, look, it's showing me as data. This is just a broken debugger. It's showing me as data from the renderer 2D class, which is ridiculous because, yeah, it's named the same, but it's static, so it's clearly internal to this translation unit. So that's the only annoying thing with using this thing. The debugger just cannot handle my code. I don't know why. It's really annoying. And I probably should have set this to null pointer. But, like, can you please not, like, do that, man? I can't believe... And this has been an issue in, like, every version of Visual Studio. It's so annoying. I need to speak to Microsoft and tell them to fix that. Otherwise, I'm switching to Sea Lion. No, I'm kidding. I would never switch to Sea Lion. Okay, so... We've set the mono domain, we've loaded a core assembly, and now we're going to print the types. And I mean, it didn't crash. So let's look at our console and check this out, guys. Hazel.main in .module. So Hazel.main has been successfully printed, and that is what we wrote inside our C# file. So yeah, easy, right? Everything's up and running. Well, not everything. This is only the beginning, but it's pretty exciting. What I wanted to check though is what are we actually, so we're printing namespace and then name. So if we go into here, this will be interesting to kind of step into. We've only got 2 types here, it seems. And Peter, you didn't add a new line. That's why this is all weird. But let's do HZ core. I was wondering why there was that weird .module thing. If we just do trace and then we'll just do, I think we can just do that. So this might look a bit nicer if we print it. Might go back. Yeah, so we have dot and we have no namespace and just module as like some weird class, I guess. And then Hazel.main. So not sure what that module thing is, maybe some kind of default thing for the DLL. But if we go through this, we can see we've got 2 types. And then we obviously pull out. So we've got a few of these things, I guess, that we can field list, method list. A few of these things we can kind of pull out. But then we get the namespace and name, which again, there's just like some weird blank module one, I guess. Inside the metadata. So this is obviously just, we're just looking at the metadata that's contained within the assembly. So if we load a more exciting assembly, we'd see more stuff, right? So as an example, what I'm actually going to do is I'm going to go into, so earlier we downloaded Forest, right? So I'm going to go into Forest and I'm going to just load its assembly instead. So that way we'll get some more exciting things. So inside the Forest directory, we have data, assets, scripts, binaries, ld50 gameplay.dll is what it's called. So if we just kind of paste that in to where we put this thing, which was resources scripts, and we load that instead, which at the moment it does not matter what we actually load, right? But let's just run that. You can see what we've got here. So we've got that .module thing, and then we've got all of these classes, right? So these are all of the classes that were inside that binary. We've got the namespace, and then we've got all of the things. So this is great because obviously we're going to be able to use these later, you know, to be able to, I don't know if there's a better way to retrieve classes than just looking at the metadata like that, but this is going to be useful because we'll be able to see what's in the binary and then let people select like which class specifically they want their entity to take on so that it gets some kind of behavior. Okay, cool. So yeah, that's great. That's working. I'll revert that and I will delete that. I will delete that LD50 gameplay thing. All right, so moving on. The next thing I'll probably try and do, I don't know if Peter's guide continues. I mean, it's got tables, rows, columns. This is just metadata stuff, so I don't know. This is probably useless to us. I'm hoping to refresh this and see like an additional section, but I guess that's it. So basically, what I want to do next probably is like our goal, I think, for today, hopefully we can do this in about half an hour. But I think our next goal for today is going to be to try and obviously execute the kind of stuff that we've written here, right? So we could obviously iterate through various fields and assemblies and stuff like that. Not exactly sure how to do that and like whether or not it would be good to use this stuff for it, because there is like a method list. So I guess we probably could, I don't know what this method list thing is though. We could try and just print this. I don't know what that is. Like if that's something we then need to, if that's like something we need to dig deeper into, or if it's just gonna like appear here, or what is gonna happen. No, it's just got this thing called module, I guess. So that's kind of it. So I don't know how that works exactly. I mean, what are these? These are uint32, and then we access it in here. Yeah, I don't know how this works. Because we do actually use a different technique to, a different technique. We use different code to load, like to get access to all the methods and stuff. But yeah, so now I'm going to obviously turn to Hazel to see if I can steal these, some of our code to see how we can basically like load and call that function. Now, as far as I understand, like there's a few components to this, right? The main thing that we actually have to do is create an object out of it. So we're going to keep it real simple. Again, we're obviously starting simple, but basically the first thing we need to do is like create an object. And this is obviously going to be a managed object because it's running inside the C# like virtual machine. So, yeah, Peter, about the guide, like, I don't know what to say about that. Like, we'll see how we go, I guess. But basically, we'll create, like, step one is obviously to create the object. And then once we have the object, we should be able to call function. And then I want to be able to call function with parameter. So this will obviously create an object and call constructor. Like, that will kind of happen automatically by creating the object. So you can see over here that we've written a constructor that actually will print something. So that's exciting. And then we're going to try and call this as step 2, and then step 3 we'll call this. And the music has stopped, so let me just keep that going. Yeah, good. So that's kind of what we're thinking of doing. Yes, this will be uploaded to YouTube onto the Cherno Unplugged channel. Okay, so so first step is, how do we create an object? Well, let's take a look. Now, unfortunately, some of this code has become a little bit more specialized, but I think the crux of it is we call mono object new. Now, I don't know exactly where this is located inside metadata object, which we should probably include. Metadata object. So mono object new, and then what does that take in? So that needs a mono domain and a mono class. So we need to be able to extract a mono class, which we'll talk about as well. The domain obviously is going to be the domain we created, which is our app domain. And then the mono class is something that we obviously need to like somehow kind of extract, right? And I believe there's something, and I could just, you know, use, there's this get managed class by ID, which we have like some kind of cache. Yeah, mono class from name or something. Mono class. We could just look at it honestly. It's not that hard. Mono class get, that gets a class by a type token, but I think there's a way to get it by name. Yeah, mono class get name. No, that's the name of a class. Is there like a get? Well, let's just go to this thing, and we can just basically browse through this and see what they've got. So mono class get by ref type get namespace. So you can see all of these useful kind of functions that we can use in general once we have the class. Or maybe it's from the assembly actually. Oh, you said it's from the top? Class from name. Oh yeah, okay. So namespace and name. So I don't know, is that what you use, Peter, to build up the cache? So as far as I'm aware in Hazel, we actually go through all the assembly scripts and then create classes out of them so that they're ready to go. Well, not create classes, but obtain their mono class pointers so that they're ready to go. But basically, so this obviously takes in an image, which we should have because we loaded it. Although, didn't we close the image? And why does it use an image? Shouldn't it need an assembly? No, mono image. Huh. Oh, is that what you do? You open up this thing and then you load the thing. We use mono class get with the token that represents the class. And how do you get the token? Do you think it's worth me doing that? Or maybe not for this thing? But also, I don't understand. If you've closed the image, then is that fine? Like, how am I gonna access that? Loop through the entire assembly to get it. Okay. And is that using like this table metadata? I can't use that image. Okay, right. So I can loop through this. But how do I get the kind of, what did you call it? You called it a, you can get proper image by calling mono assembly get image. Oh, mono assembly get image. Yeah, that's right. Okay. So mono assembly get image, and then we do s data core assembly. So now we have a mono image assembly image. So then we can do mono class from name. We pass in the image. We give it Hazel and main, right? Because Hazel and main is what we've created here. Hazel is namespace, main is the name of the class. And that gives us a mono class. And then we can pass in a mono class here to create a new instance of this class, right? And that obviously returns a mono object pointer. I'll just call it instance. So now we've got an instance, and now I believe, so that I guess should call the constructor by itself. I mean, let's put a little hz core assert false into here just because I want to break the debugger. I don't want it to go past this, but let's, doesn't call the constructor. Assertion false failed. Oh, that's this one, right? Okay, it clearly doesn't call the constructor. So to call the constructor, let's see. The problem is, yeah, we don't really use this exact approach. Oh, no, we do. We do use mono object new. So let's see. And where is that called from? Mono runtime object init, apparently. Okay, I just want to quickly see if mono runtime. So init runtime object, and what if we don't have a parameterless constructor? So what do we do if it's not parameterless? Yeah, but what if I want to? What if I don't? What if I want to create an object? I get that that function will probably assert, but what is there a different function that we should call? Mono. Oh, you need to get the mono method. Okay, that makes sense. Yep. Okay, cool. So in that case, mono runtime object init. And then we pass in the instance. So these two lines basically will create the instance called the constructor. And then if we wanted to, so how do we get the method? Mono get method. But again, is there a name situation we can call? Because this requires a token. And also, I guess it'd be nice to go through all of the methods that we have in general. But let's see if this calls a constructor. Yeah, cool. So there we go. See? Main constructor. So we've now executed C# code from within Hazel, basically. Within Hazel's runtime, which is pretty cool, using mono. Now, obviously, that's step one. That's been done. This is step one. I mean, we need to retrieve the class first, but the next step is to call that function. So, So basically what we'll do is call function. Okay, so yeah, it's so difficult because yeah, again, the reason why this is kind of difficult is because obviously like the way that we do it in Hazel is just a bit more advanced than this. So I'm doing it kind of the raw way, the easy way. Eventually we'll move to a system where we basically find out everything about the assembly up front, we cache it, we store it away, and that way it's ready to go and we can organize it into our own data structures and deal with it as needed. We'll set something like that up probably fairly soon, I imagine. But yeah, for now, we can use, you know, monoclass from name and like to do this. Obviously, you don't really want to do this because you can see I'm having to use strings here. Like who knows what they're called. If you know the exact name, that's great, but it's much better to kind of Alt-Shift-S is the shortcut to Visual Assist to find symbol. But anyway, it's a lot better to obviously kind of just be aware of everything that exists. It's kind of like what we do with shaders, right? Using Vulkan, well, using SPURV, like reflection and doesn't matter, OpenGL, Vulkan or whatever. We don't want to just, you know, set uniforms by name and just hope that the name is correct. We want to be aware of everything that is in the shader so that we can then make sure that what we're doing is correct, right? But anyway, so to call the function, we will do mono class get method from name. So the class is going to be our mono class. The name is going to be whatever we called it here, which is print message. And then parameter count is going to be, I guess, 0, right? Would be this parameter count. So that's a mono method. What's it called? Print message. So print message function. And then we're gonna call mono runtime invoke with that method. So the object we're gonna provide, I guess, will be instance. And then parameters, I guess we can just do null pointer. And then if we wanted to have some kind of exception handling stuff, I think that's optional. We can also provide it, I guess, here. So let's see if that does anything. Okay, no crashes. Yep, hello world from C#. So that's working, beautiful. By the way, yeah, this assertion failed. Don't be afraid of that. That's just because I've written an HZ core set false, that's why. So it's fine, nothing's failing. Okay, so, and then to call method with parameters, so print message, print custom message func. So that's going to be print custom message. We're gonna look it up here, right, by name. Get rid of those things. And then we'll invoke it. But then here we have to provide some parameters. So the thing is, we've chosen to provide a string parameter. We probably should have started with, let's start with an integer. Print int value, just because I want to show you guys how to pass that in as well. And I want to make sure I know how to do it as well. So we'll do that and we'll do, so print int. So print, we'll keep this around, but we'll just do print int function. And that has one parameter, and then this one also has one, but we'll deal with that later. And then we'll do mono runtime. Hopefully this will work like I think it will, but we'll do mono runtime invoke. And then you can see we have a void pointer of pointers. Right, so what this kind of is our parameters as like void pointers, I think. So if we have one parameter, we can kind of set it up like this, I guess, where we have the pointer to some kind of value. So if we have a value of like 5 that we want to print, we make an array. I mean, it doesn't have to be an array, to be fair. Like we could have just said, this would, I guess, be, we could just do void void pointer value, void pointer param equals value, right? And then we could have done and param, like memory address of param. I think that would work. And then we won't do these yet. Let's try that. Yeah, Nightbot's a bit weird. Okay, so that called the wrong thing, probably because I'm a weirdo. Yeah, I didn't invoke this one. Okay, that did not work. So I'm guessing it didn't like my parameters. Thanks for letting me debug this perfectly. That should be the same, shouldn't it? Yeah, I don't. Well, method was null pointer, so I think it's just not. Oh, I didn't build the binary. Okay, let's go back to trying it my way. I didn't rebuild it, so I couldn't find the method. That's why it's nice to kind of assert after that, I guess. Yeah, there we go. See, 5. It doesn't have to be an array. It just has to be a pointer. It's the same thing. Okay, so there's our 5. Yeah, but the thing is, if you have multiple integers, right? So if I have print int, and if I have print ints, and there's int value 1, int value 2, or whatever. And I build that. Then in that case, that's where you need to have your print ints, 2 parameters, and then here we have 2, and then we have value, and then I'll have a value 2, which I'll set to like, I don't know, 508 or something. And then in this case, we don't use that because that's already a pointer. And then we just do, or rather it's already an array, it's already a pointer of pointers. So we'll just do params, and then obviously we'll make sure we have 2. And then if we run that, then it should work. And I probably didn't invoke it. I never invoke the right function. Okay, so there's 5 and 508, so we now have multiple parameters. And now finally, I want to take in a string, which will be the super thing to take in. So basically, there's a function called monostring from UTF-8, I think. Great. Let's take a look at these other ones. Yeah, there's two UTF-8, which is how we get monostrings to that. But how do we get a monostring from UTF-16? Is it really a monost? Is a monostring new? Yeah, it is. Okay, I found it. So monostring new, and then domain, because we have to actually create a string like in the managed language. So as data app domain, and then the text will be whatever we want it to be. So like hello world from C++, right? So there's that. That gives us a monostring. And then print custom message, and then I guess we just take it in like a normal parameter, right? So we just say void string param equals, that's already a pointer, so I'm assuming that will probably work like that. Sometimes it's hard to know what you're talking about, but yeah, so string param, and we're invoking this one, so let's see if that works. I don't know. Yeah, easy. So, yeah. So no problems at all. That's demonstrating quite a wide variety of things. Obviously, like, we don't want to necessarily like do it exactly this way, and this will change as time goes on, right? But it's the base. This should be enough to get you started, right? You can imagine that if this was like some sort of you know, entity class, and it had like an update function on update with like a time step, then you should be able to figure out what to do from here, right? You could use all the code that we've written here today to basically make that happen, and that could be the beginning of your scripting. Now, it's going to be pretty useless though in C# if you can't call back into C++. That's obviously going to be a bit weird, right? Because obviously we want to do certain things, such as like, I don't know, move the entity. And for that, we need to modify the translation. So we need some kind of API to get into C++. So we're going to do that using internal calls. And so basically it'll be like mono add internal call. And then you'll basically add like a specific way or whatever. I don't know if we still use that, Peter, but yeah. Yeah, no, of course, like manage thunks and whatever, and there's a lot of depth to get into, but that's not something that we're going to cover today, obviously, and probably not for a while either, because this is like the easy way that will probably work for most people, and it's a little bit easier to obviously get started without getting too complicated. But yeah, in the future, we will obviously expand this. Our goal is to ship a 2D game using all of this text, so, and obviously with Hazel Dev, like, or Hazel 3D, we've shipped and will ship more 3D games using it. So it's obviously something that we want to improve over time and have it be fairly performant and handle like, you know, a whole game. So it's going to be important to make sure performance is good and everything is working as best as we can. But that's basically like the this is a good start, I think. Obviously, we're not shutting down anything. I don't know if we want to go through that now. I guess we can. We probably, I don't know, do we need to close this image that we loaded? Maybe not. Because we didn't really load it, did we? Mono assembly get image. Does this need to be released? No. Okay, yeah, I didn't think so. So we basically just need to... what do you do in shutdown? Monojit cleanup. Hey, what's up, fan of Cherno? So in shutdown, we can just do monojit cleanup, and that's the domain. And is there other stuff that we need to do? So we do git cleanup with the domain, apparently. Yeah, that's... Oh, it should be root domain. Oh, because we made a root domain. I forgot about root domain entirely. Yeah, root domain is what we did with there. And then do we need to release some kind of other domain or whatever? Or does that just release everything? But what's the root domain even used for? Because we haven't used the root domain. That's just like monojit init created like the root domain, and that's it. That's the last time we heard about the root domain. Which is kind of interesting, but I guess that's okay. It's used for very little stuff. Cool. All right. But it is used. But don't we have to, do we have to release, I guess we do have to release this app domain as well, right? I forgot what the thing is. So, unload app assembly or something. Do we do that? I'm looking through the Hazel code and I don't see it. Wait, what does post load cleanup do? Up here. Monodomain unload. Yep. Monodomain unload. And then we'll do sdata app domain. So let's kind of make sure that works, maybe. So in application, inside here, we'll do renderer shutdown. I guess we can do script engine shutdown first. Renderer is probably nice to shut down last. Let's just make sure this is called as well. Oh, and I can get rid of that assert. I'll leave it in as a little comment. Yeah, so we've got all of our stuff working here. Then if we close it, we get this script engine shutdown. That seems to work, no errors. Yeah, that's fine. And then obviously if we wanted to, we could set them to null pointer. I might do that just to... I mean, I don't know if we'll necessarily shut down Mono and then reboot Mono again within the same app lifecycle. But if we do, obviously that's going to be important to kind of have these here. Okay? Apparently just setting app domain to null pointer works as well. You can't. Oh, you can't reboot Mono again in one lifecycle. Great. Well, whatever. This way it will diagnose in case we shut down earlier than we need to. Apparently just setting app domain to null pointer works as well. I don't buy that at all. What do you mean setting app domain to null pointer works as well? It's just a pointer. That won't actually unload it. Unless I'm misunderstanding you. But anyway, that's it, guys. That's the beginning. So let's go ahead and commit this. We'll see what we'll go a little quick recap over what we've done. 653 changes. Sounds about right. Oh, shutdown doesn't call shutdown Mono. Thanks for that. Versus Tune said. That was your first time chat, and it was a good one. So we'll do shutdown Mono, and then we delete the data as well, which just means that setting them to a null pointer were very useful. So let's make sure that actually works. Oh, it doesn't. Of course it doesn't. I knew it didn't. It's too easy. It would be too easy if Mono shut down. Oh, this is the domain unloader thread. Great. I guess we probably shouldn't have... Do we need to wait for it to be unloaded or something? Because it runs on a different thread. We've got the source code here. I just want to see, is unloading if domain state. I mean, this probably... We could just do a little while unloading sleep or whatever if it's actually like that. But see, this is why I don't like doing shutdown stuff. It's better to just close the app and get out. Wait for thread. If thread data done or guarded wait. No. Let's go to exit. Mono threads close thread handle. This almost implies that it does wait for the thread. Oh, try unload. If doing things the right way is too hard or complex, we do it the simple way, which means do everything you need to avoid crashes and memory leaks, but not much else. Nice. So domain unload. Oh, domain unload actually calls try unload. What does this do? Okay. You don't need to manage your memory if you just close the app. That's true. See? I'm right. Oh, look, there's a guarded wait here. Well, this clearly doesn't wait, right? Because the thing is, what's it doing? It's crashing. Where's it crashing? Let's run that again quickly. Oh, well, I'm in release. Oh, that's mono. Pfft. No, stop. I don't want to run mono. What's going on? Stop. This is what I meant. I was looking through the source code. So it crashes here. What's the main? Where's the main thread at? Main thread's waiting. Oh. Oh. So it is waiting in domain try unload. So this is a correct wait. So this is waiting. It's waiting for the signal. Yeah, it's waiting for a signal. And then the domain unloader's upset because there's no table. But it's waiting inside. But it's waiting inside the first thing we try to do. So how has that happened? That's weird. Mono get hazardous pointer. But that's already been deleted somehow. That is so interesting. So in critical region, we pass false for try. Monitor info table, find internal. Why is it doing all of this? Oh, because it's trying to do it one final GC. Unload thread main. And this is all coming from where exactly? Unload thread. Unload thread main. Okay, this is just the unloading thread. Right, okay. Oh, I see. I think I see. Okay. So this is looks like some kind of unloading thread main function, which I guess gets spinned up at the beginning, and then it's probably chilling here like just running GCs or doing unloading or whatever. And then now it's been terminated, so it's doing a domain free and then a GC collect. Wow, how can it do a GC collect after a domain free? Isn't that within the domain? Weird. Because look, this domain's been deleted. This domain has clearly been deleted, probably by, you know, this function, mono domain free. And yet, you're gonna do a GC collect. Which isn't that then going to go into the domain? Or is that supposedly a different domain? Because look, it's passing the domain in. That's why it's failing. Because the domain doesn't have anything. It's been deleted, bro. You just deleted it. Is that the same domain? 2E BD0. BD0. Lol, it is. Alright, mono people. So you free a domain and then proceed to do a GC collect which involves the domain. Big brain. Big brain. I mean, I have no idea how any of this works, guys. So I'm just being a clown. But that to me sounds like it should be that. But who am I to say anything, you know? Should we try that? Should we try and compile a binary with that one change and see if it fixes it? That would be pretty epic. Where's my bug bounty or whatever? I want to cash in. App domain.c. What was it? 3322. I mean, that can't be that simple. Wait, what? All right. Where even is this? This is in libs mono. I guess libs mono static would include it though. That's the release binary. Let's build debug. All right. All right. You jokers. Let's see what happens. We're gonna have to revert that soon. All right. Oof. That just flat out gives an assert. I don't think even mono knows how to shut down mono. Oh! That's in JIT cleanup though. We made it past domain unload with that. Huh. We made it past domain unload. Problem solved. Maybe this is a different bug. Oh, now it's doing some domain finalize, but it doesn't matter. Either way, the domain would have been gone. This is the root domain probably. Maybe it has the same problem. No, this one's still alive, kind of. And get that bug bounty. So what's your problem? Oh, this is on the main thread though, at least. Oh, that's it. So we successfully shut down that thread. So as far as I'm concerned, that's solved. But what's this? What's your issue? You tried to log something. I guess there's no log domain, but that's fine. So if level is error, so it tried to log an error. Did it log anything? What the heck is this? Oh, that's, I don't know what that is. Should not be reached. Okay. Should not be reached. Oh my god, half of this is an assertion message. Okay, right. So it didn't it's upset because the desk is 0. And it shouldn't be 0 because this should never be a default state. So this is some sort of illegal state. And what is this, bro? Look at this, like, what is this? Is this a function? This looks like something you include into a function. Why would they write code like this? Look at this thing. Look at this thing. Begins with a parenthesis, has a billion, like, if defs, and includes a switch statement. It's kind of like a macro, but it also seems to be in a separate file, partially. So yeah, so desk is 0. What even is this? Okay, whatever. I don't think I'm gonna deal with this. I don't really care. Some kind of garbage collection. Garbage collector couldn't collect mono. Ooh, burn! Domain finalize. Timeout. These GCs, bro. These GCs. This is why you don't have a garbage collector. There's no guarantee that if I didn't run my code, if I didn't change my code, this probably wouldn't have worked anyway. I still maintain that I did fix something though. It's just, this is like, I just don't understand. I mean, this is an assert, let's be real. So can we just, I mean, it's an abort though. So we can't really continue, can we? Well, whatever, application closed. So as far as I'm concerned, job done. But yeah, I don't know. That's a bit weird. I guess I probably shouldn't do what I did. Or at least, we'll remember this between us stream. But I'll change this back to what it originally was, since I'm going to commit the binary. But I do maintain that possibly was a valid fix. Because it seemed to... So, okay, so this was 808. So this is the new one. We're going to put it into here. Okay. Now, also, like, I mean, we don't need any of these other things, right? So if I, let's see, because we probably already also have a PDB for this, don't we? Oh, there is no PDB for this. Oh, wait, yeah. What? So do we only need this? What do we commit? This stuff's useless, right? We're not using any of this. Is that right? Oh, we should probably try building release as well, by the way. I mean... So we'll relink that. Yeah, I don't know. I don't think we need anything else for now, so I'm not going to commit anything else for now. Wait. Did that just work? Okay, so it's, yeah, it's a race condition. Beautiful. That's what we want. Okay, let's go back to script engine. And yeah, I'm just going to... Just add a little note there, and we won't do the shutdown. Okay, whatever. Okay, so I think what I'm going to do now is Sarnal. That's a good point. I should do that. That's great. Okay, so yeah, release is what I wanted to try. And I guess with release as well, we can probably make sure that we don't have too many binaries. Because I think we just need this. So there's an exports library file. Wait. Why do I have an exports file? But I think it's just that. Wait, is that it? This looks completely different. Yeah, and it's got an exports file. What? Oh, I copied the wrong one, I think. This is the one. I was going to say, because that looks like the DLL version. Okay, lib mono static sgen. So build, we'll build that in release. Building in release. It built. It ran. We got all of our C# code. Yeah, cool. All right, ship it. So local changes 627. So application, pretty straightforward, just adding this stuff. Script engine, obviously a lot of messy code here. This is very much work in progress. It is on the scripting branch. So we'll just add that in for now, doesn't matter. Scripting engine, cool. Mono. So we don't need everything. Like, I don't think we need this opcode.def file. What even is this? Yeah, I'm just gonna get rid of that. We'll include all the headers, I guess. So all the headers will include. That's a lot of stuff. We'll include the two libraries, license and readme, as we decided. And then the pre-make, obviously, we need to include, as well as... Okay, so there's probably some stuff we should add to the git ignore. So the intermediates directory is a really good place to start. So if we take a look at... Let's close mono, we don't need that anymore. If we take a look at our git ignore, let's add... intermediates. We shouldn't just bin, we're not building to bin, so it's okay, but we need to be careful about that. We don't want to exclude that. CS proj files. So we have got VCX proj, but we'll do CS proj files as well. We will exclude because they get generated by pre-make. Yeah, everything else looks pretty good. So that's our C# code. That's our Hazel script core thing. Our git ignore we obviously just updated, and dependencies and this pre-make as well, which is all good. I'm GUI we won't worry about. And then the thing is, if we don't, oh, this isn't a scripting branch. Yeah, guys, just build your own script core. We won't commit this. I guess we could. It's only 4 kilobytes. That way people could just run it without having to compile it. I mean, it'll build into the right place. So, the only reason why, guys, is because at the moment, if you open the repository, Hazel script core is not like a dependency of anything, so it won't build. If you just like set Hazelnut as your startup project, which it should be by default, and you just run it, this will never build. So you have to go right-click build, or you can obviously build the whole solution, Control-Shift-B. But if you don't do that, then you're not going to be able to load the file. So I don't know. Should I commit the binary? I mean, I don't like doing, like, obviously if it was actual code, we wouldn't do it. So I guess we don't want to remove it later. I might as well never commit it. You guys can just build it. And it is on the scripting branch, so it's not like it will crash master if you don't have it built. So I think that's probably okay. Yeah, cool. I mean, we definitely don't need all of this metadata stuff. Oh, no, actually, one thing we didn't include is this. Now, I really don't want to include all of these. I just don't. I don't want to make the repository huge. So I think what we'll do for the beginning is we'll include them maybe as needed. Because how big is this? 76 meg. I mean, it's not that bad. And it will include everything. But like, you know, there's exe files in here. Like, we don't need exe files, surely. Upload them to hazelengine.com and then setup script can download them. Yeah, I don't really want to do that either. If you install Mono, you'll get them. I guess I should include this as part of the engine, though. I mean, sure, it makes it a bit bigger, but this will never change, and it'll be compressed in the Git repository, so it's probably okay. Because that way, like, we don't know how people are going to use Mono, right? Like, as in, you don't know how people are going to use this, and so having to add your own binaries could be annoying. So yeah, maybe I will leave it. MS build, that's okay. I mean, it's not like nothing in MS build. And facades. Yeah. Yeah, again, I just don't know. So I'll just include them, I think. It's okay, it's not a big deal. All right, cool. So in that case, this is being included. And yeah, that's it, I think. Fork's not responding. If Fork crashes, we won't include all of it. All right, it didn't crash. Cool. Yeah, that's it. So that's like all we've done today. I'm gonna push it, I guess. Initial C# script engine work. Okay, cool. Yeah, that's it. So let's push that, commit and push. And then if we head on over into the Hazel repository, once this actually gets pushed, if you guys have any questions, now's a good time to ask. Damn, this was a kind of a long live stream, but we did it. We had some serious work. We got some serious work done, which is nice. We had some time for some story time as well, which is good. All right, so that's it. You can see we have scripting has recent pushes less than a minute ago. So we have this new scripting branch, and on that scripting branch is where all of our stuff is, right? So if you guys clone this branch and run it, just make sure that you build Hazel script core using Visual Studio or whatever, and as long as you have the DLL in the right place, you should be able to run it. And obviously see the code that we wrote, like in C# here, being called inside the console, which is pretty cool. And like, obviously you can do whatever you want in the C# code and call it, right? Like we could write a file from here, we could do anything. And now we're kind of all calling it from Hazel, which is pretty exciting. So yeah, will C# scripting be integrated into the ECS/scene similar to the native scripting? It will probably be a lot better than that, because the native scripting was kind of like a, hey guys, this is how we can write some code in a very simple way. And I wasn't really serious about it because we don't want to, like, we weren't really going to support that properly anyway, because C# is going to be the main scripting language, right? And then obviously if you want to if you want to write certain parts of your game in C++, you can do that, but the idea is you call that in from C#. everything kind of goes through C#, and you can write some functions natively if you want to, and that should be very easy to integrate. So yeah. Anyway, thank you guys for watching. Hope you enjoyed this episode. Very long episode of the Game Engine series. Don't forget that you can help support the series by going to patreon.com/thecherno, and you'll get access to the big version of Hazel, where we've done a lot more work. And that's kind of a preview of what's to come, obviously, for this series as well, since we'll be writing a script engine similar to, and a scripting system similar to that. And I will be here next week, almost same time. Today we streamed on Tuesday, but it's going to be on Monday. So if you check the Twitch.tv schedule on my channel, then you will see kind of when it will be next time. But yeah, next time, obviously, we're going to continue with the scripting. We're going to probably, I don't know if we'll build up those caches exactly, but we will probably talk about how we can actually call back into C++ code from C#. I think that'll probably be a good thing to cover. And maybe we'll try and extract some more metadata. We'll see, so that we can display it like an IM GUI. Yeah, that'll be fun. So yeah, thank you guys for watching. Have a great rest of your day or night, and I'll see you guys next time. Goodbye.